Good afternoon from NASA's Kennedy Space Center in Florida. I'm Stephen Clark, editor of Spaceflight Now. Welcome to our live coverage for the Artemis 1 countdown and launch to begin the first test flight of NASA's Space Launch System moon rocket from Kennedy Space Center. Right now, the launch team is undergoing their final preparations to start loading propellants into the Space Launch System moon rocket out at pad 39B. The mission management team gave their approval to start propellant loading a short time ago, and launch director Charlie Blackwell-Thompson will soon give her approval to begin loading propellants into the Space Launch System. That will begin with the chill down or thermal conditioning of the transfer lines leading from ground storage tanks up through the mobile launch platform into the core stage of the moon rocket. So liquid hydrogen and liquid oxygen will both be loaded into the core stage, followed by loading of the same propellants into the upper stage. If everything goes well, NASA hopes to launch the moon rocket at 1:04 a.m. Eastern Standard Time. That's 6:04 a.m. UTC at the opening of a 2-hour launch window. NASA just confirmed that launch director Charlie Blackwell-Thompson gave her go to start cryogenic tanking of the Space Launch System moon rocket. So with that approval, the next step will be the thermal conditioning or chill down of those transfer lines to start loading propellants into the vehicle out at pad 39B. This is the third launch attempt for the Artemis 1 moon rocket, following attempts back in late August and early September that were cut short by a sensor problem initially on the first launch attempt on August 29th that gave some false indications that one of the core stage engines was not being properly chilled down for launch. The following launch attempt a few days later, on September the 3rd, was scrubbed after the detection of a significant liquid hydrogen leak in the tail service mast umbilical. That's the connection point between the mobile launch platform and the core stage itself. Since that scrub in early September, a lot has happened since then, beginning with the change out of seals in that connector. That was followed by a tanking test on September the 21st that succeeded in fully tanking the Space Launch System. That was planned to set up launch attempts in late September and early October. However, Hurricane Ian struck Florida in the last week of September. NASA moved the rocket off the pad back into the vehicle assembly building for shelter from Hurricane Ian, and that prevented any launch attempt in October. NASA returned the rocket to the pad on November the 4th in preparation for another series of launch attempts beginning this week. The launch attempt that NASA initially targeted was November the 14th, but NASA delayed the flight 2 days after Hurricane Nicole hit the east coast of Florida last week. But with only minor damage reported, very minor damage reported to the moon rocket, which rode out the Hurricane Nicole on the pad, NASA teams and NASA managers cleared the way for another launch attempt, the first in a new series of launch attempts this evening into tomorrow morning, with the early morning launch window again opening at 1:04 a.m. Eastern Time or 6:04 a.m. UTC. There is also an update to the launch weather forecast. The last few days, the forecasts have indicated a 90% probability of favorable weather. That has slightly degraded to an 80% odds of go weather. The main change has been with additional cloud cover that is forecast to be over the Space Center tonight. It's currently overcast at Kennedy Space Center this afternoon. and NASA, or the Space Force's 45th Weather Squadron, which provides forecasting for launches from here on the Space Coast of Florida, is now predicting a broken deck of clouds at about 12,000 feet at launch time. That is a slight change from the earlier forecast of scattered clouds. The main weather concerns for the launch window are with thick clouds and cumulus clouds, both of which are related to the risk of lightning that could be triggered by the rocket as it climbs through the atmosphere. There are stringent restrictions on the thickness and height of the clouds and the amount of electrical charge that those clouds may contain. Even if there is no thunderstorm in the immediate area, those clouds could still contain electrical charge and have the risk of lightning as the rocket climbs through them. But hopefully that's not an issue tonight. The odds are it won't be, with an 80% chance of good weather predicted for the launch window overnight for Artemis 1. Here's a view from the Kennedy Space Center press site showing the countdown clock, which is holding as expected at T-minus 6 hours and 40 minutes. That hold began a little more than an hour ago. It's a 3.5-hour hold. This is a pre-planned hold. No impact to the launch time from this hold. NASA reports that everything is looking very good right now, a green board, as they head into final preps to start loading propellants onto the Space Launch System. If you're just joining us, again, welcome to our live coverage for the Artemis 1 countdown and launch. We're reporting live this evening from Kennedy Space Center. If you haven't done so yet, please hit the like button here on our stream. That helps us gain a larger audience for our coverage. We want as many people watching this exciting countdown and mission as possible. So again, please hit the like button here on our stream. That goes a long way to help us out. We're now about 9.5 hours until the opening of the launch window tonight at Kennedy Space Center. That's quite a long countdown ahead as NASA prepares to load more than 750,000 gallons of cryogenic propellants into the Space Launch System moon rocket. Again, this is the first flight of the Space Launch System. It's also the first time an Orion spacecraft will have traveled to the vicinity of the moon. An Orion mission back in 2014 performed tests in Earth orbit. NASA has worked on the Space Launch System for more than a decade now to prepare this rocket for its inaugural test flight today. Over the course of that decade of development, the Space Launch System moon rocket alone has cost more than $20 billion in development expenses to date. So a very crucial test flight of this 322-foot tall or 98-meter tall launch vehicle is on tap tonight. If everything is on schedule, we expect to have confirmation of the start of liquid hydrogen and liquid oxygen chill down in about 4 minutes or so. We're streaming views from different NASA cameras out at Launch Complex 39B. In this view, you can see the part of the core stage of the Space Launch System and one of its strap-on solid rocket boosters. Again, we're not controlling this camera. This camera is being controlled by an engineer over at the Launch Control Center. But NASA is providing this feed and other camera views to us throughout the countdown. So we may see some zoomed in views here. This shows one of the attach points at the base of the solid rocket booster, connecting it to the core stage. The solid rocket boosters will burn for about 2 minutes and 12 seconds, providing roughly 3/4 of the thrust needed to power the rocket off the ground. At that point, those two solid rocket boosters will jettison from the core stage and fall into the Atlantic. They won't be recovered on this mission. The core stage, with its 4 liquid-fueled main engines, will continue heading downrange to the east-northeast from Kennedy Space Center out over the Atlantic Ocean. The core stage will burn its engines for about 8 minutes. And then it too will separate from the upper stage of the Space Launch System. The core stage will fall back to Earth, burning up primarily most of it will burn up in the atmosphere on re-entry before it completes an orbit of the Earth. And the core stage, or the upper stage rather, will perform 2 engine burns with its RL-10 engine. First to reach a stable low Earth orbit, and then a second burn about 90 minutes after liftoff will be the trans-lunar injection, or TLI burn, to send the Orion spacecraft out toward the moon. But before we get to that point, NASA needs to fully fuel the Space Launch System here at Kennedy Space Center and run through the countdown, complete all the checks on the vehicle, and that will culminate with ignition of the 4 main engines on the core stage about 6 seconds prior to launch, and then those 2 powerful solid rocket boosters will ignite when the clock reaches 0. About 8.8 million pounds of total thrust at liftoff is what the 2 boosters and 4 engines will be producing. Here's a nice view from the top of the mobile launch tower out at pad 39B, looking down on the Orion spacecraft. The Orion spacecraft here is covered with the aeroshell from the launch abort system. That will be jettisoned about 4 minutes after launch, after the rocket reaches space. Below that, with the NASA meatball logo and the European Space Agency insignia, those are aero panels over the service module of the Orion spacecraft, which is provided by Europe, by the European Space Agency in partnership with Airbus. The Orion crew module, the pressurized element that will carry astronauts on future flights, is built by Lockheed Martin. So you can see here the countdown clock remains in a pre-planned hold at T-minus 6 hours and 40 minutes. If you're just joining us, we'll ask you one more time to please hit the like button here on our YouTube stream. That helps us gain a larger following for this coverage of the Artemis 1 countdown and launch. We're here at Kennedy Space Center in Florida, awaiting the scheduled 1:04 a.m. Eastern Time, 6:04 a.m. UTC launch of NASA's Artemis 1 test flight to the moon. If you look at the upper left of our feed here, you'll see the countdown clock continues holding at T-minus 6 hours, 40 minutes as planned. This is a built-in hold. Below that, we have a second clock that is counting down in real time to the opening of the launch window, now 9 hours, 9 minutes away. It'll take the better part of 6 hours to fully load, or to thermally condition and then load both stages of the Space Launch System rocket. NASA has confirmed that chill down of the liquid oxygen and liquid hydrogen transfer lines is now underway, right about on schedule this afternoon. This involves flowing small amounts of the super cold fuel and oxidizer through the transfer lines, leading from their respective storage tanks at the pad up to the mobile launch platform area and up to the interface of the mobile launcher with the core stage right at the tail service mast umbilical. That's the appendage you see here sticking up, the gray component, a gray piece of hardware sticking up just to the left of the rocket above the mobile launch platform. That's where propellants are loaded into the core stage during the countdown. NASA has changed the loading timeline a bit for this launch attempt after some lessons learned from the previous launch attempts on August the 29th and September the 3rd, both of which were scrubbed due to technical issues, namely a hydrogen leak in that tail service mast umbilical interface area. NASA technicians changed out some seals in that umbilical plate area of the tail service mast umbilical, and then adjusted some of the timelines and techniques and procedures they use to load propellants into the rocket. They are using what they call a kinder, gentler approach to loading liquid hydrogen into the core stage. This has been a finicky system on this vehicle and on the mobile launch platform for months now, dating back to the initial fueling tests on this rocket back in April. One of the key points in the loading timeline is the transition from slow fill to fast fill mode. That occurs a little bit later in the countdown. If everything is on schedule, that is expected to occur at around 5:14 p.m. Eastern Time, that transition from liquid hydrogen to slow fill. Before then, they'll have to transition from chill down to slow fill, and then switch from slow fill to fast fill later on at 5:14 p.m. Eastern. And as they do that, they will be ramping up the pressure that they use to flow the liquid hydrogen very gently, instead of a more quick, a faster switch to fast fill mode. They'll be taking a slower, more gentle approach to that to try to keep that seal in the umbilical plate area at the tail service mast in place and to prevent any significant leak in that area. The system is designed to tolerate a small leak in that area up to a certain percentage of concentration in the single digits of a percentage of hydrogen concentration, but if it gets above about 10%, at that point the system would be violating safety constraints, and they would go into what is known as a reverse flow and stop loading hydrogen into the vehicle to try to eliminate that leak. The safety limit generally is 4% concentration for liquid hydrogen in that area, but NASA engineers this week, and press briefings earlier this week, mentioned that they can tolerate up to about 10% for a very short period of time during that transition if they see a brief spike in hydrogen concentrations, that's going to be okay as long as those concentrations come back down to within acceptable levels quickly. So several moments of truth ahead in this countdown here at Kennedy Space Center. You can see here we're taking advantage of the multiple views we're getting from NASA. On the right is a camera position on the eastern perimeter of Launch Complex 39B. On the left is a camera that's mounted on the mobile launcher tower itself, looking at one of the umbilical arms connecting up to the core stage. I believe that is the intertank umbilical, if I'm not mistaken, that we're seeing on the left here. You can see the two nose cones of the solid rocket boosters, with one of those boosters having the black band around its circumference there on the right in this view. That's in place to help tracking cameras and the launch team keep track of which booster is which, basically, during the ride uphill and after jettison of those boosters for their fall back into the ocean. Those two black checkered marks you see on the boosters there are also useful for NASA to help track the exact orientation and position of the rocket during its climb to space. There are also checker marks on different parts of the rocket as well. This is basically used to help, basically for calibration purposes for tracking cameras, for scale, to know exactly the position and orientation of the rocket during launch. NASA reports that the chill down or thermal conditioning of the liquid oxygen transfer lines has been completed. That will be followed in about 10 minutes or so by the start of slow fill of liquid oxygen. That's when propellants will actually start loading into the core stage for this Artemis 1 countdown. Chill down of the liquid hydrogen lines continues. Here's a view of a look at some of the milestones ahead in this countdown. We've passed the first of these bullet points at 3:44 p.m. Eastern Time, actually a couple of minutes ahead of schedule. The transfer line chill down began for liquid oxygen and liquid hydrogen out at pad 39B. With liquid oxygen transfer line chill down complete, the liquid oxygen slow fill will begin shortly. The core stage liquid hydrogen slow fill will also begin in the next hour or so. Once those slow fills are complete, they'll transition to fast fill. And then another major milestone will be at 5:27 p.m. Eastern Time, 22:27 UTC, the start of the engine bleed kickstart. That's when a little bit of liquid hydrogen from the core stage begins to flow down into the main propulsion system at the bottom of the core stage to begin conditioning the 4 RS-25 engines. And then at 5:54 p.m. we expect the countdown clock to resume from its current hold at T-minus 6 hours and 40 minutes. And then once that countdown clock resumes, the core stage will be in fast fill on both tanks. That'll take a couple of hours to complete loading the core stage. Once that's complete later this evening, loading will begin on the upper stage. Continuing to stream views from the Kennedy Space Center press site. About 4 miles from Launch Complex 39B, you can see some of the media representatives here positioning their tripods and equipment for photographing this launch tonight. The launch window runs 2 hours and opens at 1:04 a.m. Eastern Standard Time, 6:04 a.m. UTC. Again, if you're just joining us, please hit the like button here on our stream. It helps us a lot with gaining a larger audience for our coverage. So please hit that button if you can. Also, we want to give a big thank you to Space Pony for gifting 5 Spaceflight Now memberships. These memberships help us maintain and expand our coverage of the space industry and launch activity here on Florida's Space Coast and around the world. So if you want to take advantage of that, please consider becoming a member of our YouTube channel. We have different membership levels available for you to choose from. Depending on which level you select, you can gain access to exclusive members-only video features that we have from our coverage here at Kennedy Space Center and at Cape Canaveral. Also, please subscribe to our YouTube channel. And if you do that, you'll receive alerts when we're going live with our launch coverage. As you can see, it continues to be an overcast afternoon here at Kennedy Space Center. That cloud layer is expected to persist through much of the evening. The official forecast calls for that cloud layer to perhaps break up a bit by launch time. The forecast calls for broken clouds at 12,000 feet during the 2-hour window tonight. But there's an 80% probability of acceptable or favorable weather for launch. This view from Launch Complex 39B, you can see the base of the two solid rocket boosters on each side of the core stage of the Space Launch System. And those boosters, as well as the core stage itself, have that same checker pattern painted on them that I talked about earlier for camera tracking and calibration purposes. At the very top of this view, the orange pipe, essentially, that enters the outer skin of the core stage there is one of the liquid oxygen feed lines that flow. Those are used both for loading of liquid oxygen into the vehicle during the countdown, as well as the flow of liquid oxygen from the oxygen tank, which is on top of the liquid hydrogen tank, down to the engine compartment. And here's the top end of that liquid oxygen feed line, where it exits the liquid oxygen tank on the core stage, and you can see that line runs down the length of that 212-foot long core stage. On each side of that feed line are cable trays and systems tunnels. Those run cables and wiring up and down the length of the core stage. If you look closely down at the very bottom of the core stage, you can start to see some vapors down below the engines. That's from the main propulsion system chill down, which is now underway out at Pat 39B, as cryogenics are now being flowed through some of the engine compartment plumbing. Here's a nice view of the 4 RS-25 engines at the bottom of the core stage. Again, this camera now panning away from that view. We're not controlling these cameras. These cameras are under the control of the NASA launch team. We're continuing to receive really nice camera views from different cameras out at Launch Complex 39B as NASA's launch team surveys the entire Space Launch System and Orion spacecraft stack. Now pointing at the very top of the stack, the launch abort system for the Orion spacecraft here. For this mission, if you look closely, you can actually see the word inert stenciled in on that launch abort system. That's because the launch abort system is not active for the Artemis 1 mission. On future flights, this launch abort system would be used, if necessary, to pull the Orion spacecraft off the top of the Space Launch System in the event of an in-flight failure. With no astronauts on this mission, the launch abort motor is inert, so that will not be active or an option for this mission for Artemis 1. The launch abort system does have a jettison motor that is fueled with solid propellant and will be used to pull that aeroshell and the launch abort system stack off the Orion spacecraft after it reaches the upper atmosphere. It's about 4 minutes after liftoff. The camera is now panning down. We've passed the Orion spacecraft itself, now pointed at the top of the core stage where it connects to the launch vehicle stage adapter. That's the conical section that connects the core stage with the smaller diameter upper stage of the launch vehicle. And here is one of the umbilicals that connects to the top of the core stage. The entire core stage is covered in this orange spray-on foam insulation that is designed to eliminate the buildup of frost or ice on the outside of the rocket as super cold propellants are loaded on board. The foam also helps insulate the tanks themselves to keep them as cold as possible to minimize boil-off of those propellants during the countdown. NASA has just confirmed that liquid hydrogen slow fill on the core stage of the Space Launch System is underway. So fuel is now flowing into the core stage of the Space Launch System. On previous countdowns, the liquid hydrogen loading began a little bit later in the countdown sequence. NASA has adjusted that to start loading hydrogen fuel a little bit earlier in the countdown timeline to enable this more gentle approach to loading hydrogen. The hydrogen loading will take longer than it has during the previous launch attempts today in order to minimize the risk of any leaks, which have been a persistent issue for the Artemis 1 launch campaign. This liquid hydrogen slow fill did begin about 10 minutes behind schedule. It was due to begin at around 4:19 p.m. Eastern Time. Began around 4:30 based on our report from NASA Launch Control. In the background here, you can see some of the marsh at Kennedy Space Center, some wildlife in that marsh. Kennedy Space Center is co-located with the Merritt Island National Wildlife Refuge here on Florida's Space Coast. The camera now panning down the length of the height of the SLS stack. You can see the NASA worm logo emblazoned on the solid rocket booster in red here, and the word loaded there, indicating that that booster is indeed fueled with its solid propellant. It's been loaded with its solid propellant for a couple of years now, since it was cast back at Northrop Grumman's booster fabrication facility in Utah. It's a nice view of the two of the four RS-25 engines, one of the nozzles of the Space Launch System Solar booster here. Some vapors becoming more visible now as the main propulsion chill down continues and liquid hydrogen loading is underway on the core stage in slow fill mode. That will be transitioned to fast fill later on in the countdown. That transition to a fast fill should be about 30 minutes, maybe 40 minutes away. It was due to begin at 4:59 p.m. Eastern, but we do know that the liquid hydrogen slow fill began about 10 minutes behind schedule. This is not expected to be by itself any impact to the launch time. There is some flexibility in the sequence in the countdown timeline itself. So this alone will not is not expected to impact the target launch time of 1:04 a.m. Eastern time. I mentioned a few moments ago that the casting and propellant of the Solar boosters began a couple of years ago. It was actually back in 2016 when the casting of the solid propellant in the segments of the Solar boosters began out in Utah at Northrop Grumman's booster factory. NASA just confirmed that slow fill is underway for liquid oxygen on the core stage. So both cryogenic propellants are now being loaded onto the core stage. These are the largest propellant tanks on the vehicle. And that will be followed later on in the next half hour or so by the transition to fast fill. Here's a view of the tail service mast umbilical area at the base of the core stage. This is where propellants are being flowed into the core stage right now. On the left is the liquid. On each side, there's one for liquid hydrogen, one for liquid oxygen, where propellants are being flowed into the core stage. Both of these propellants are loading in slow fill mode. This is to minimize the thermal shock as these propellants are loaded into the vehicle. The liquid oxygen is chilled down to about minus 298 degrees Fahrenheit. Liquid hydrogen is colder still at minus 423 degrees Fahrenheit. Again, as you can see, the sky over Kennedy Space Center remains gray with overcast clouds over the launch pad right now. A bit of sun there on the horizon as we're now less than an hour from sunset here on Florida Space Coast. Everything so far this afternoon has been progressing on schedule, more or less. A slight delay to the start of liquid hydrogen tanking, but no impact from that is expected on the launch time. The launch window opens at 1:04 a.m. Eastern Time, 6:04 a.m. UTC. About 8 hours, 21 minutes from now. On the upper right here, the official firing room countdown clock continues to hold at T-minus 6 hours, 40 minutes. This is a pre-planned or built-in hold that is scheduled to end in a little more than an hour. We should see that clock resume. We've added the clock time remaining until the opening of the launch window below that. Again, 8 hours, 21 minutes until the opening of the launch window. NASA Launch Control reports that liquid oxygen is now flowing into the core stage in fast fill mode. Slow fill mode continues on liquid hydrogen on the core stage at this time. The core stage liquid hydrogen will continue in slow fill a bit longer than the liquid oxygen had to go into slow fill mode. All told, NASA's launch team will be loading about 755,000 gallons of super cold propellants into the Space Launch System this evening. The largest tank by far is the first stage or core stage liquid hydrogen tank, which will contain about 537,000 gallons of fuel, chilled down to about minus 423 degrees Fahrenheit. Liquid oxygen on the core stage, that tank is 196,000 gallons in volume. That is already now in fast fill mode. And then later on in the countdown, once the core stage is full, attention will turn to loading the same propellant mix on the interim cryogenic propulsion stage. That's the upper stage of this Space Launch System moon rocket. About 22,000 gallons of cryogenics will be loaded into that element of the rocket. Again, that's a couple of hours away now. Attention now is focused on loading the core stage. On the left-hand side of your screen is a camera view from one of NASA's cameras out at Pad 39B on the mobile launch tower, looking at the bottom of the core stage and the bottom of the liquid oxygen feed line, one of the two liquid oxygen feed lines on the vehicle. That white section is the engine section of the core stage. Above that, the orange part is the bottom of the liquid hydrogen tank, which is now being filled in slow fill mode on the core stage. Liquid oxygen, that tank is above the liquid hydrogen tank on the core stage. It is now in fast fill. Again, NASA's launch team is controlling where these cameras are pointing. We'll often see it zoomed in on specific elements and components of the rocket. Right now you're looking at one of the attached fittings between the solid rocket booster and the core stage. As you can see, the countdown clock continues holding at T-minus 6 hours 40 minutes. This is a built-in hold that will end at 5:54 p.m. Eastern. We should see that clock resume then. Below that, we're now 8 hours until the opening of the launch window for Artemis 1, which is scheduled to begin at 1:04 a.m. Eastern Standard Time. That's 6:04 a.m. UTC. The launch window will run for 2 hours. This will be a middle-of-the-night launch for NASA's Artemis 1 moon rocket. That's the most powerful rocket ever developed by NASA, as measured by liftoff thrust. 8.8 million pounds of thrust will be coming out of the 4 core stage engines and the 2 side-mounted solid rocket boosters at liftoff. And assuming the launch occurs tonight, the Space Launch System will take the mantle for now as the most powerful operational rocket in the world. That claim is currently held by SpaceX's Falcon Heavy. NASA reports that the liquid hydrogen is now just past the 5% mark and will soon be transitioning to fast fill mode. This is a key moment that in previous countdowns has resulted in the detection of leaks, or a leak, around the tail service mast umbilical, where the propellants are flowed from the mobile launch platform, the ground side systems, essentially into the core stage. But NASA has adjusted the propellant loading sequence and timeline for this launch attempt. They tested it back on September the 21st during a tanking test, which was successful. They were able to fully load the Artemis 1 moon rocket with propellants during that cryogenic loading demonstration back in September. And they're going to use those same procedures today in hopes that they achieve a similar result with no significant leak. There was a bit of a leak detected back on that September the 21st tanking test, but it was within safety parameters. Here's another view of the Space Launch System moon rocket from a camera on the western perimeter of Launch Complex 39B. We've been showing a view from the eastern side throughout the countdown. Here's a view from the west perimeter camera. We're now about 20 minutes or so away from sunset. NASA Launch Control has confirmed that the core stage liquid hydrogen loading has transitioned from slow fill to fast fill mode. This is using pressure from the ground cryosphere, the storage tank, to essentially push the liquid hydrogen from that tank through the transfer lines into the core stage, slowly ramping up pressure to switch from slow fill to fast fill to enable the more rapid loading of fuel into the core stage. About 537,000 gallons of liquid hydrogen will be loaded this evening. Liquid oxygen is already in fast fill mode on the core stage. The view here on the left-hand side of your frame is a camera view from the tail service mast umbilical that looks at the connections from the mobile launch platform onto the core stage. On the left is the liquid oxygen loading line. On the right is the umbilical that holds the liquid hydrogen loading line. Now 7 hours, 37 minutes until the opening of tonight's Artemis 1 launch window at 1:04 a.m. Eastern Time, or 6:04 a.m. UTC. Here's a gorgeous view of the Space Launch System on Pad 39B this evening as the sun is setting on the western horizon. This view comes from a camera on the eastern perimeter of the pad looking west. Fast fill continues on the core stage for both liquid hydrogen, liquid oxygen. And in the last few minutes, we heard a report from Launch Control that the kickstart bleed is underway on the liquid hydrogen system for the 4 RS-25 main engines. This begins the process to gradually bring those engines down to cryogenic temperatures throughout the rest of the countdown. That reduces the risk of thermal shock as the super cold propellants flow into the engines at ignition. Cameras out at Pad 39B continue panning up and down the Space Launch System, taking a look at the exterior of the vehicle for any concerns or issues. So far, no issues of any importance reported in this countdown. We're going to tune in now to NASA commentator Daryl Nail talking to Jeremy Graber, the Assistant Launch Director.
We're in the middle of our tanking operations. We picked up with those tanking operations just a few hours ago. Our launch director, Charlie Blackwell Thompson, said some great words to our team, and they're actively loading cryogenic fuel into the core stage. So far, everything is going very smoothly, and we're about 25 minutes from coming out of our hold at T-minus 6 hours and 40 minutes. And we've got about an hour and a half of liquid hydrogen fast fill to go, and about 2.5 hours of liquid oxygen fast fill to go. Our teams are monitoring the progress of that loading, doing a great job, and things look really good right now.
The team seemed upbeat when I was at the MMT meeting. A lot of positive vibes all the way around. Charlie Blackwell Thompson, launch director, didn't have a constraint when she walked into the room. And then, as you mentioned, things have been going pretty well. Now that we're in tanking, this is an area that we have seen issues in the past. The fast fill for liquid hydrogen, especially when we get into the bleed. We're currently in that kickstart bleed, but so far, so good. And there's a different loading operation that was used for this time.
Yeah, this team has done a fantastic job working through each of the different wet dress rehearsals and launch attempts. In addition, we did a tanking test that demonstrated a lot of updated procedures to deal with the challenges that we had seen previously, and this team has really been outstanding, finding the right sequencing, the right basically keeping everything in a very tight box to ensure that we manage through any potential issues, and so far everything that they've put in place has been going extremely well, and we'll just keep monitoring as we go.
Yeah, this is as close to the countdown as you lay it out on your bar chart, as they called, that I've seen through 4 wet dresses and 2 launch attempts, and this of course being the 3rd.
Absolutely, we are right on the timeline, which is as a launch guy, that's where I want to be, right on the timeline.
That's right. Had to deal with a hurricane. Had to deal with 2. Obviously, the rocket was inside the VAB for 1, and for the 2nd, it was out there for tropical Hurricane Nicole, rather. So far to this point, have you noticed anything that you would attribute to the hurricane?
Well, so one of the really key things that we've been doing since Nicole passed through is to really investigate and look at all of our systems from a powered up perspective as well as from an outside visual perspective. And we've been doing that from the minute we were able to really see that. We monitored all of our capabilities on the flight hardware and the ground systems throughout the storm, and we've been keeping a very close eye on everything since the storm made it through. And so far, we've worked through any of the items that we found. I know some of those things have been talked about at the mission management meetings over the last couple of days. We came in to call the stations for launch countdown. We had some work that we carried in. We've made it through all of that work yesterday, and we really have a clear constraints board at this point. Have not seen any issues associated with, normal issues that may have come up, or from anything else. So, as I said, clear constraints right now and on the timeline.
That's one tough rocket out there, as come to find out. You mentioned the couple of issues that were dealt at the MMT meeting, some of the RTV that came off the seal below Orion, and then along with a connector that was in the same location as a previous hydrogen leak. But you've got redundancy there, so you're good to go, and it looks like that is not going to be an issue as we proceed forward. We're headed to sunset. As you can see, sun just went down here at the Kennedy Space Center as the lights are on and illuminating the Space Launch System rocket. Getting an update. Engine stand by. So, Jeremy, we just heard from the NASA, from the liquid hydrogen team on the NASA test director's loop. They're reporting out right now. The engine bleed is complete. They did see a little bit of hydrogen in the area, a little bit of leakage, a little over 4%, but that apparently went down. That's within your range, right?
Absolutely, that's it within our range. That's an expected leakage rate at that location, and as you mentioned, the great thing is wherever it got to at that 4%. Since I'm not looking at data right now, I'm
sure.
But the good thing is it started coming down as they completed the bleed. So that's exactly what we would expect to see, and based on that, it sounds like we're still doing great.
That seal in that quick disconnect, it has to conform, right, to that space there. And when you hit it with those cryos, that's kind of part of it, right? Just like you were saying. It's
yep.
Kind of
And our expectation through the rest of loading is that leakage rate will come down. That's really what we saw during the tanking test that we performed after the last launch attempt. And so we really do expect to see that leakage come down as we load the core stage tank, the liquid hydrogen tank, and you get more commodity on board. That will really help seal that, and we should see that come down.
All right, great news. Real-time update from our Assistant Launch Director, Jeremy Graber. I really appreciate that. Thank you very much for being here, and good luck to you and the team the rest of the way.
Thanks, Daryl. Appreciate it.
All right, we are...
That was the voice of Daryl Nail, NASA TV's launch commentator for Artemis 1, interviewing Jeremy Graber, the Assistant Launch Director over at the Launch Control Center just across the road from our position here at the KSC press site. You heard from Jeremy Graber that everything is looking good. He said things look really good right now. We are right on the timeline. About 90 minutes remaining in fast fill for liquid hydrogen. About 2.5 hours remaining in fast fill for liquid oxygen on the core stage. And that'll be followed by loading of cryogenic propellants on the upper stage of the SLS moon rocket out at pad 39B. So as you heard, the launch remains on schedule for 1:04 a.m. Eastern Standard Time. That is 6:04 a.m. UTC. One more time, we'll ask you, if you haven't had a chance to do so already, to please hit the like button on our YouTube stream here. That helps us gain a larger audience for our coverage. We're going to be with you throughout the night into the early hours of Wednesday morning as we cover the countdown and the initial phases of the flight of the Artemis 1 mission up through the deployment of the Orion spacecraft from the Space Launch System on the way to the moon. Here's a nice view here as the skies darken over Kennedy Space Center, looking down at the Orion spacecraft. That's the payload for this mission. That's a human-rated spacecraft that is being sent on a mission around the moon, a mission that is now slated to last about 25 days. It'll perform various checkouts and testing of its navigation, communications, life support systems around the moon, and then will depart lunar orbit, and assuming the launch occurs tonight, splashdown of the Orion crew module in the Pacific Ocean is scheduled for December the 11th. That's about a 25.5-day mission. The mission duration for Artemis 1 is varies. It can be what NASA calls a short class mission or a long class mission, depending on when the launch occurs during each launch period. Just the orbital constraints of this mission necessitate that the Orion spacecraft fly on a short class mission of about 25 days. You may recall, if you've been following the Artemis 1 launch campaign back during the initial launch attempts on August the 29th and September the 3rd, the orbital dynamics for those launch attempts would have had Orion fly a long class mission of about 6 weeks or so, about 42 days from liftoff till splashdown. The difference is the difference in those durations is essentially for this launch attempt, for this mission profile, assuming a launch occurs tonight, the Orion spacecraft will complete a half lap around the moon in what's called a distant retrograde orbit. This is a high altitude retrograde or reverse direction orbit around the moon that the Orion spacecraft will insert itself into. So it'll complete a half orbit of the moon over the course of about a week or so. For the longer duration missions that are possible with other launch dates, the Orion spacecraft would fly 1.5 laps around the moon before returning to Earth. Here's another good shot of 2 of the 4 RS-25 engines. These engines at the bottom of the core stage have been refurbished and recycled and upgraded from the Space Shuttle program. NASA retained 16 flight-ready, flight-capable Space Shuttle main engines after the retirement of the Space Shuttle program in 2011. They kept those engines around and have upgraded them with new engine controllers or computers for use on the Space Launch System. So the first 4 flights of this new SLS moon rocket, beginning with Artemis 1 and extending up until Artemis 4, which is going to be launching later in the 2020s, will all use engines left over from the Space Shuttle program. In the long run, NASA has contracted with Aerojet Rocketdyne to build new RS-25 engines for use on later flights of the Space Launch System. The 322-foot tall Artemis 1 launch vehicle is lit up by stadium lights and spotlights out at pad 39B this evening. It is on the horizon, quite visible on the eastern horizon here from our position at Kennedy Space Center, with those lights lighting up the bright white of the solid rocket boosters and the Orion spacecraft, and that distinctive orange color of the foam insulation on the core stage. In this view, we're looking at a shot of the Space Launch System from our camera at the Kennedy Space Center press site, about 4 miles away from the pad. You can see the 2 of the 3 lightning protection towers here with the flashing aviation hazard lights on each side of the rocket. Of course, behind the rocket itself is the mobile launcher, the tower, that stands about 375 feet tall. And then just off to the right, behind the rocket, is the water tower that holds the water used for the sound suppression system. That will be dumped onto the launch pad and the launch platform deck in the final seconds of the countdown to dampen acoustic energy from the startup of the engines and boosters at liftoff. And then off to the very, very far right of the frame, that flame, is the liquid hydrogen flare stack that is burning off hydrogen gas that may be building up around the launch pad area during the tanking operation. It helps reduce the risk of any fire or explosion as the hydrogen is loaded into the vehicle. Of course, hydrogen is a very flammable, very potent propellant. That's why it's used as the fuel for the Space Launch System. And behind, just to the right of the water tower, if you look closely against the dark horizon, you'll see the top half of a white sphere. That's the liquid hydrogen storage tank. That's where the hydrogen that's actually being flowed into the rocket at this time is stored on the ground at the pad. We're now 7 hours and 22 minutes from the opening of the Artemis 1 launch window here at Kennedy Space Center. Again, just to recap, propellants are being loaded into the core stage right now in fast fill mode. That includes liquid hydrogen and liquid oxygen, chilled down several hundred degrees below zero. And the report we heard a few minutes ago from NASA Assistant Launch Director Jeremy Graber is everything is looking really good right now for a launch opportunity later tonight. Here's a graphic provided by NASA showing the current status of propellant loading on the core stage. You can see liquid oxygen is at 35% full. Liquid hydrogen has just passed the 40% mark, so not quite half full on both tanks. Still a couple of hours to go until the core stage is fully loaded. 7 hours, 16 minutes until the opening of the launch window. As you can see the temperatures, you can see the liquid oxygen is chilled to about minus 294 degrees Fahrenheit. Liquid hydrogen currently being measured at minus 423 Fahrenheit. We expect to see the countdown clock pick up at T-minus 6 hours and 40 minutes and about 30 seconds or so. This built-in hold in the countdown lasted 3.5 hours. It's one of 2 holds in the countdown. Should see the countdown clock resume in less than 10 seconds. There we have it, T-minus 6 hours, 40 minutes and counting. There's one more hold remaining in the countdown. That's going to be at T-minus 10 minutes, when the clock will hold for a half hour. During that hold, Launch Director Charlie Blackwell Thompson will poll her team over at the Launch Control Center for a final go for launch before entering the final 10-minute terminal countdown sequence. No issues reported so far this evening at Kennedy Space Center as propellant loading on board the core stage continues. Here's a look at the latest stats on the status of fueling and propellant loading on the core stage. Liquid oxygen now at 43%, liquid hydrogen at 58% full. Here's a new look at the status of propellant loading on the core stage. Liquid oxygen, which loads slower than the liquid hydrogen, is now half full. Liquid hydrogen now at 76%. So propellant loading continuing on track this evening at launch pad 39B. 6 hours, 49 minutes until the opening of the launch window here at Kennedy Space Center. We're continuing to stream live views from cameras at different locations out at Launch Complex 39B. These are NASA cameras that they're providing us access to this evening. NASA is controlling where these cameras are pointing, but we are able to bring you a variety of different angles on the Artemis 1 moon rocket as it awaits its launch opportunity overnight tonight. This view shows the engine section of the core stage with the RS-25 engines visible there at the bottom of the core stage. Those RS-25s are leftovers from the space shuttle program. As you can see here, liquid hydrogen is now at 87% full. That will transition back to it'll transition to a topping mode when the liquid hydrogen tank reaches about 95%. That will dial back the flow rate to top off the liquid hydrogen tank on the core stage. Liquid oxygen, which loads slower, now at 56%. And as liquid oxygen is flowing into the core stage, we're now seeing some more visible gas vapor venting from the top of the liquid oxygen tank out at pad 39B. This is normal as the liquid oxygen boils off in the warm Florida atmosphere. Once the tanks are full, and after they're topped off, they will transition to what's known as replenish mode, and the liquid oxygen and liquid hydrogen will be gradually replenished. A little bit of those propellants will be pumped into the rocket to replace what boils off throughout the hours remaining until liftoff. We're now 6 hours and 40 minutes from the opening of the launch window. The countdown clock, as you can see here, is at T-minus 6 hours, 10 minutes. That includes 30 minutes of hold time that is planned when the clock reaches T-minus 10 minutes. That's a pre-planned hold at 10 minutes, during which the launch director, Charlie Blackwell-Thompson, will poll her team for the final go to enter the terminal countdown. Throughout the year, we've been bringing you live coverage of major events in the Artemis 1 launch campaign. We covered the tanking tests and wet dress rehearsals back in the spring and over the summer. And of course, we covered the Artemis 1 launch attempts back on August the 29th and September the 3rd, followed by the rollback for Hurricane Ian and the return to the launch pad 11 days ago for this launch attempt. If you want to help us continue to provide live coverage of events like this, you can support our coverage by becoming a member of our YouTube channel. We have different membership tiers available for you to choose from. Depending on which one you select, you can gain access to bonus video features for members only. And you'll help us continue to bring you live coverage like this, as well as the increasing rate of launch activity here at Cape Canaveral. After this launch attempt tonight, SpaceX is planning to launch a pair of Falcon 9 rockets from here at the spaceport in Florida on Sunday and Monday. We'll be bringing you live coverage of that as well. So there's a major event or launch going on multiple times per week here at Kennedy Space Center and at Cape Canaveral Space Force Station, and your support really matters. It helps us continue to do what we've been doing for 23 years almost, since the Spaceflight Now website went live back in 1999. You can also support our coverage by contributing here in the Superchat function on YouTube. That's another option for you. So we'll ask you to please consider that if you can afford it. It would really help us out. Also, please subscribe to our YouTube channel. You can do that for free, and you'll gain alerts as we're going live for live launch coverage. Really quiet countdown this evening, with no issues reported from NASA's Launch Control Center. Everything looking good right now with propellant loading. NASA reported that there was a slight detection of a small hydrogen leak early on in the loading procedure this evening, but the concentration of hydrogen in that umbilical area at the base of the rocket quickly dissipated and went back under the allowable limit of 4%, and that is allowing the countdown to proceed this evening on track for the 2-hour launch window for Artemis 1 opening at 1:04 a.m. Eastern Time, or 6:04 UTC. NASA Launch Control just reported that the fast fill of the liquid hydrogen tank on the core stage of the Space Launch System is complete and is transitioning to topping mode. Liquid oxygen is at 64% full on the core stage. About an hour remains in the liquid oxygen loading this evening, according to NASA Launch Control. The tanking operation this evening is going very smoothly, very close to the timeline. So right now, preparations are right on track for the opening of the launch window at 1:04 a.m. Eastern Time, or 6:04 a.m. UTC. This has been probably the smoothest countdown so far for the Space Launch System moon rocket so far, at least as they got into propellant loading, with no significant leak detected in the hydrogen loading system. We're bringing you a split screen view. On the left is a view from one of NASA's cameras out at pad 39B, zoomed in on the top of the core stage near one of the umbilical arms that extend out from the mobile launch tower to the top of the core stage. You can see the gaseous oxygen venting from the top of the core stage. That's as expected as the oxidizer boils off throughout the countdown. On the right is a camera view from the eastern perimeter at pad 39B, looking edge-on at the 322-foot tall, 98-meter tall Artemis 1 moon rocket. And the latest update from NASA Launch Control is that the liquid hydrogen tank on the core stage is now replenished. So that marks the completion of the loading operation on the liquid hydrogen tank on the core stage. The name replenish, as it might suggest, indicates that the liquid hydrogen will be slowly replaced on the core stage as some of that boils off throughout the rest of the countdown. So the first of the 4 cryogenic propellant tanks on the Artemis 1 moon rocket now full. With the confirmation from NASA that liquid hydrogen loading on the core stage is complete, here's a look ahead at what's next in this evening's countdown. The liquid hydrogen topping and replenish actually occurred a bit ahead of schedule. That was due to occur at about 6:54 and 6:59, but those two milestones have already been checked off. They're done. The next thing we'll be watching for is a couple of things. One, it will be the completion of loading of liquid oxygen on the core stage. That should transition to topping mode in about an hour at 7:49 p.m. Eastern Time, 12:49 a.m. UTC. And about 10 minutes later, the core stage should be transitioning to replenish, much a similar procedure as we just saw with the liquid hydrogen on the core stage. In parallel with some of these activities, preparations will begin to load cryogenic propellants on the interim cryogenic propulsion stage, or ICPS. This is the upper stage of the Space Launch System that is responsible for accelerating the Orion spacecraft, powering it on a trans-lunar injection maneuver to send it toward the moon. This ICPS was provided by United Launch Alliance and Boeing. The core stage is a Boeing product. At 7:44 p.m. Eastern, the ICPS liquid hydrogen ground support equipment and tank chill down procedure should get underway. 15 minutes later, at about 7:59 p.m. Eastern Time, the ICPS liquid oxygen main propulsion system chill down should begin, and also liquid hydrogen loading, fast fill loading on the ICPS upper stage should also begin at 7:59 p.m. Eastern Time. 10 minutes after that, at 8:09 p.m. Eastern, liquid oxygen on the ICPS will begin loading at fast fill, and at that point, liquid hydrogen should be in topping mode. The tanks on the ICPS are much smaller than the tanks on the core stage, so they don't take as long. There's no multi-hour loading process for the tanks on the upper stage. And once those milestones are complete, here's a look at what we can expect later on in the evening. The Orion spacecraft will go through some RF communications checks at around 8:44 p.m. Eastern Time. The liquid oxygen on the ICPS upper stage should be in topping mode at 9:24, and both tanks will be on the upper stage will be in replenish mode around 9:39 and 9:44 p.m. Eastern Time. At 10:04 p.m. Eastern Time, the Eastern Range here at Cape Canaveral will perform their hold fire checks. This is part of the range safety apparatus that allows the range and the range control officer to send a hold fire command to prevent launch in the event of an issue with the range in the final moments of the countdown. At 10:24 p.m. Eastern Time, we should see the core stage gyro compass alignment. This is part of the inertial navigation system on the core stage to align its gyro compass for the flight to space tonight. At 10:49 p.m., we'll see the flight termination system testing. The flight termination system is the range safety system that would destroy the Space Launch System moon rocket in the event it veered off its predetermined course and threatened any populated areas. That FTS includes pyrotechnics that would basically blow up the rocket if it flew off course after launch. At 10:59 p.m. Eastern Time, the launch day trajectory file will be uploaded to the rocket's flight computer, and then at 12:04 a.m. Eastern Time, we expect to see slew or steering checks of the upper stage RL-10 engine. That's part of the flight control system checkout on the upper stage. And then at 12:24 a.m. Eastern Time, the launch countdown will enter a 30-minute built-in hold once the clock reaches the T-minus 10-minute point. And during that 30-minute hold, Launch Director Charlie Blackwell Thompson, at around 12:49 a.m. Eastern Time, will perform her launch readiness poll. So this is the poll of the launch team over at the Artemis Launch Control Center in the firing room here at Kennedy Space Center to verify that all stations, all consoles are ready to proceed into that final 10-minute terminal countdown. And later on this evening, we'll have another slide like this showing what we can expect inside that 10-minute terminal countdown sequence. Some of the major events that are occurring once the clock picks up, all the way up until liftoff. So that's a look at what we can expect to see over the next few hours if everything continues to track as it's going so far, quite smoothly. Now 6 hours, 15 minutes until the opening of the launch window. Here's another view from Launch Pad 39B as propellant loading operations continue. Just to recap, liquid hydrogen on the core stage has been fully loaded, and liquid oxygen continues to load in fast fill mode. And once the core stage loading is complete, we'll switch over to loading the upper stage. This view from camera 814 on the mobile launcher out at Pad 39B shows one of the liquid oxygen feed lines that runs the length of the core stage. These camera views are being controlled by NASA's launch team here at Kennedy Space Center. You can zoom in on some of the brackets on the core stage. You can get a good sense of the texture of the spray-on foam insulation. It looks like there's a bit of frost or ice built up on that particular bracket on the outside of the core stage. This is not unexpected because if you remember, the propellants on board the rocket are very, very cold. Liquid hydrogen at about minus 423 Fahrenheit, liquid oxygen at about minus 294, 298 degrees Fahrenheit. So these are very cold fluids that are loaded into the core stage. And that foam insulation is designed to minimize the ice or frost buildup outside the rocket, but there are some areas where we may see some minor frost accumulation on the outside of the core stage. Of course, these cameras are being remotely controlled by the launch team. There's no one out at the launch pad at this time with the hazardous loading of propellants underway. The Launch Control Center is located about 3 to 4 miles southwest of Pad 39B, right next to the Vehicle Assembly Building here at Kennedy Space Center. And the team in charge of this countdown is operating out of Firing Room 1 of the Launch Control Center. As you can see, we're now less than 6 hours from the opening of tonight's 2-hour Artemis 1 launch window here at Kennedy Space Center. 30 minutes difference in the T-minus clock from the firing room and the actual time until the opening of the window. Again, that's due to that 30-minute built-in hold that is coming up at the T-minus 10-minute point. The latest update from NASA Launch Control is that the liquid oxygen tank has passed the 81% full mark. That was as of a few moments ago. Liquid hydrogen, of course, is full on the core stage, and in a short period of time, preparations will commence to load cryogenics onto the interim cryogenic propulsion stage on the Space Launch System. That stage will contain 22,000 gallons of propellant, and in comparison, contrast that with the 733,000 gallons of propellant on the core stage. You can get a sense of the differences in scale of these two stages on the Space Launch System moon rocket. You can see a more vigorous stream of vapor appearing outside the gaseous oxygen vent at the top of the core stage as that liquid oxygen boils off. Now, 5 hours, 55 minutes until the opening of the launch window. Here's another look at NASA's propellant loading graphic for the core stage. Liquid hydrogen at 100% as we've reported, and liquid oxygen now passing 84% full. That will transition from fast fill to topping mode after it reaches above a level of about 95%. And then that liquid oxygen tank will be topped off to a total capacity of 196,000 gallons. Here's a view inside Firing Room 1 at Kennedy Space Center, where the Artemis 1 launch team is watching the countdown, managing the countdown this evening. This is in the Launch Control Center, which is right next to the Vehicle Assembly Building here at Kennedy Space Center, around 3 to 4 miles from Pad 39B. Right now, the work is focused on preparing the upper stage of the Space Launch System, built by United Launch Alliance, for propellant loading. About 22,000 gallons of liquid hydrogen and liquid oxygen propellants will be loaded into this upper stage. We just heard confirmation from NASA Launch Control that the liquid oxygen tank on the core stage is now in topping mode. So we're nearing completion with propellant loading on the core stage. Liquid hydrogen has been fully loaded now for more than an hour. No issues to report right now in the Artemis 1 countdown. Everything looking good for liftoff during the 2-hour window tonight, opening at 1:04 a.m. Eastern Time, 6:04 a.m. UTC. latest report we've received from NASA's Launch Control Center is that the liquid oxygen tank on the core stage is now in replenish after being topped off. So it's now in replenish mode. And with that, the core stage of the Space Launch System is fully loaded with 733,000 gallons of cryogenic propellants, 537,000 gallons of hydrogen, 196,000 gallons of oxygen. And that was accomplished without any significant leaks, according to NASA. The next step in this evening's countdown will be loading of the same mix of propellants, liquid hydrogen and liquid oxygen, onto the interim cryogenic propulsion stage. This is the upper stage of the rocket that will be sending the Orion spacecraft out toward the moon with a pair of burns using its RL-10 engine. That will occur once the rocket is in space after the 2 solid rocket boosters and the core stage finish their job in the first 8 minutes or so of the flight. A very clean countdown reported this evening so far, according to NASA. This appears to be the smoothest countdown for this Artemis 1 moon rocket to date. That includes the number of wet dress rehearsals and tanking tests, as well as the 2 scrubbed launch attempts back on August the 29th and September the 3rd. 5 hours and 16 minutes remaining until the opening of tonight's launch window. The countdown clock is heading down toward the next and final built-in hold, which is going to be at T-minus 10 minutes. That hold will last for a half hour. And during that hold, Launch Director Charlie Blackwell Thompson will poll her team for a go or no-go to enter into that terminal countdown. If you're just joining us, I'm Stephen Clark, the editor of Spaceflight Now, reporting live from Kennedy Space Center on the launch of NASA's Artemis 1 test flight to the moon. If you haven't done so already, please hit the like button here on our YouTube stream. That helps us gain a larger audience for our coverage. So if you want to do us a favor and hit the like button on our YouTube stream here, that would be greatly appreciated. This view from camera 808 out at Launch Complex 39B on the mobile launch platform shows the bottom of the core stage, the engine section. That's the white section that sits below the orange foam on the liquid hydrogen tank here, with the 4 RS-25 main engines mounted to the bottom. Here's a view of the upper stage of the Artemis 1 moon rocket, which is now being loaded with hydrogen fuel. About 22,000 gallons of liquid hydrogen and liquid oxygen will be pumped into the upper stage of the rocket over the next hour or so. The propellants are loading into the upper stage through the interim cryogenic propulsion stage umbilical, which you see here. That's located at the 240-foot level of the mobile launcher tower. And that supplies fuel and oxidizer, as well as purge air, gaseous nitrogen, and helium, and electrical connections to that upper stage while it's on the pad. And that upper stage is derived from the upper stage that's used on United Launch Alliance's Delta IV Heavy rocket. This version of the upper stage has slightly larger propellant tanks, but it uses the same basic type of engine and design. An RL-10 engine from Aerojet Rocketdyne will power this stage. That engine on tonight's mission will burn 2 times to place the Orion spacecraft onto a trajectory toward the moon. The first of those is a very short 22-second burn called the perigee raise maneuver, and that's required to place the Orion spacecraft into a stable low Earth orbit, because the core stage and the 2 solid rocket boosters will do most of the work to get the Orion spacecraft to orbital velocity, but won't quite reach that velocity level required to enter a stable orbit, so that'll leave the perigee or low point of the orbit inside Earth's atmosphere. So without a perigee raise maneuver, the upper stage and the Orion spacecraft would re-enter the atmosphere over the Pacific Ocean, just as the core stage will do on its own. So there needs to be a 22-second burn to raise that perigee above the atmosphere, and then the rocket will coast nearly for a full orbit before reigniting for a longer 18-minute burn called the translunar injection maneuver to send the Orion spacecraft out toward the moon and break the grip of Earth's gravity on the Orion spacecraft. That 18-minute burn, called the TLI burn, will be the longest engine firing in flight by any RL-10 engine. And those of you who are familiar with the launch industry will know that the RL-10 has been a workhorse. It's flown on hundreds of missions on Delta, Atlas, and Titan rockets since the 1960s. In fact, more than 500 RL-10 engines have flown to date. But this will be the longest of all those missions. This will be the longest ever burn by an RL-10 engine in space. There have been longer maneuvers before during ground test firings, longer burns before during ground test firings, but never before in space. Coming up in a few minutes, we'll pass the 5-hour mark remaining until the opening of the launch window. The countdown clock showing T-minus 4 hours, 33 minutes as the clock heads toward the built-in hold at T-minus 10 minutes. Still no issues being reported by NASA Launch Control at this time. You're looking down now on the Space Launch System from a camera on top of the mobile launch tower. There's a great view of the Orion spacecraft cocooned inside its aeroshell. That aeroshell consists of two parts, the launch abort system aeroshell on top of the crew module. Then there are panels around the circumference of the service module below the crew module. Those will be jettisoned about 3 to 4 minutes after launch. Now less than 5 hours until the opening of the launch window. Very smooth countdown this evening at Kennedy Space Center so far. As propellant loading continues on the interim cryogenic propulsion stage on board the Artemis 1 moon rocket, we're continuing to receive these views from NASA cameras out at Launch Complex 39B. The launch team is using these cameras to inspect the exterior of the rocket during the countdown. NASA Launch Control reports the liquid hydrogen tank on the upper stage is now at 18% full. Liquid oxygen on the upper stage is at 44% full. These are much smaller propellant tanks on the upper stage than the core stage tanks are. We've also seen some signs of vapors venting from the upper stage vent valves as propellants are loaded on board. And just a moment ago, the countdown clock passed T-minus 4 hours and counting. That is 4.5 hours from the start of the launch window, accounting for the planned 30-minute hold once the clock reaches T-minus 10 minutes. As we continue to monitor the Artemis 1 countdown here at Kennedy Space Center, we want to invite you once again to help support our coverage. You can do that by becoming a member of our YouTube channel. We have different membership levels available for you to choose from depending on which tier you select. You can have access to members-only video features that we have here on our YouTube channel, and you'll be again supporting our coverage to help us bring you live events like this one. You can also contribute in the Superchat function in the chat here on our YouTube stream. A few of you have done that tonight, and we thank those of you who have contributed in our Superchat. That really helps us continue to bring you live streams like this one. Also, if you haven't had a chance to do so, please hit the like button on our YouTube stream. By hitting the like button, you expose this stream to a larger audience. We can get more people watching this countdown and launch of the Space Launch System moon rocket, the most powerful rocket ever developed and designed by NASA. This rocket stands 322 feet, or 98 meters, out on Launch Complex 39B tonight. Now 4 hours and 20 minutes or so remaining until the opening of the launch window. Now 4 hours, 19 minutes until the opening of tonight's launch window. We want to thank user Artemis for contributing in the Super Chat and becoming a member of our YouTube channel. Big thank you to him or them for their support. If you want to submit questions in our chat, I'll try to answer them as we are in a rather quiet period in the countdown as tanking operations on the upper stage continue at this time. We're past some of the critical milestones of the core stage loading earlier in the countdown that have caused trouble for NASA's launch team on previous fueling attempts on this rocket. And once the upper stage is loaded with its supply of propellant, attention will turn to some flight control system checkouts on the upper stage, as well as RF communications checks with the Orion spacecraft. This is all leading up to the T-minus 10-minute hold. Question from Bill Peterson in our chat asking an estimate on how many seconds after T0 the vehicle clears the tower. The Space Launch System moon rocket will be clear of the mobile launcher tower at T plus 7 seconds. And it will actually be clearing the lightning protection towers at pad 39B at T plus 8 seconds. The rocket has a fairly high thrust to weight ratio, so it will be launching at a good pace, at a good clip. At T plus 8 seconds, when it clears the lightning protection system, the 3 lightning towers at pad 39B, it will be at an altitude of about 600 feet. In 8 seconds, it will rise 600 feet off the pad. And in those 8 seconds, it'll be traveling about 86 miles per hour. The rocket will be exceeding the speed of sound at about T plus 54 seconds. Wolfpack asks, what is the max Q time? That's the time of maximum aerodynamic stress on the rocket. That will occur a little bit after the rocket exceeds the speed of sound. Max Q is expected at T plus 70 seconds, so a minute 10 seconds after launch will be the period of maximum aerodynamic pressure on the rocket. Aeronautic Space Agency asks if we're streaming ambient audio right now on our stream here on YouTube. We are streaming some audio from the Kennedy Space Center press sites, some audio from here, but we turned that down very low because there's a lot of activity from the teams here gathered to cover the launch outside our building here at the KSC press site. Beginning at 10:30 p.m. Eastern, we will be streaming some ambient audio from the launch pad as the countdown enters the final hours before liftoff. And some news to report now. The updated launch weather forecast just briefed to the launch team here in Florida. is trending in the right direction. There's now a 90% probability of acceptable weather for liftoff of the Space Launch System tonight. That is an improvement from 80% in the previous weather briefing earlier this afternoon. The outlook calls for scattered clouds at 2,000 feet, broken clouds at 12,000 feet, good visibility, winds from the south-southwest at 8 to 12 knots, and a temperature of 70 degrees Fahrenheit. The main weather concerns continue to be with cloud cover over the Kennedy Space Center, but again, those aren't expected to be an issue with a 90% probability of good weather. Super CC asks, why is the countdown clock different from the launch window open clock? See, the countdown clock is at 3 hours 40 minutes, launch window open 4 hours 10 minutes away. So it's a difference of 30 minutes. That's because the countdown clock from the firing room will be held at T-minus 10 minutes. So when the countdown clock reaches T-minus 10 minutes, that will stop ticking for 30 minutes. That is a pre-planned hold point during which the launch director, Charlie Blackwell Thompson, will poll her launch team for a final go or no-go to enter the terminal countdown, which begins at T-minus 10 minutes. Sean Leary asks, are we at 39A or 39B? Tonight's launch is from Launch Complex 39B, which is the northernmost launch pad here at the Florida Spaceport. It was originally built for the Apollo program as a twin to Launch Pad 39A. It remained in service during the Space Shuttle program. And after the shuttle retirement, Pad 39A was leased to SpaceX, which uses that pad for Falcon 9 and Falcon Heavy launches, including crew missions to the International Space Station. Pad B was retained by NASA and converted for use for the Space Launch System. Liquid oxygen fast fill on the upper stage of the Space Launch System moon rocket has been completed. That transitions to the next step, which is a valve validation and leak test on the liquid oxygen system on the upper stage. In the next few minutes, liquid hydrogen fast fill should be completing on the upper stage. Brian V asks, will I be able to see this launch from St. Petersburg, Florida? And if skies are clear, the answer is yes. So it's obviously weather permitting based on the sky conditions at your location. But if you look off to the, I guess, east from St. Petersburg, if you have clear skies, you will see this launch. Jesse McLaverty asks, how long for Artemis to reach the moon and what has changed with the mission since the first launch attempt? So I'll take the second part of that question first. The first launch attempt was back on August 29th. That was followed by another launch attempt on September the 3rd. The attempt on August the 29th was scrubbed due to a sensor problem that was providing data to the launch team that suggested one of the 4 main engines was not being properly chilled down for ignition. That was not the case. That was a bad sensor. The chill down was apparently working. So NASA set up for a second launch attempt on September the 3rd. That was scrubbed due to a significant hydrogen leak. So since that September 3rd attempt, NASA has replaced seals in the hydrogen loading system that feeds fuel from the launch platform into the core stage. That was tested on a fueling demonstration later in September without any significant leak. And again, today, in today's countdown, we've seen that demonstrated again. No significant leak detected in that system during the fueling operation earlier this evening. So as for the other part of your question, how long for Artemis to reach the moon? Assuming the launch occurs tonight or Wednesday morning during the window opening at 1:04 a.m. Eastern Time, the Orion spacecraft is scheduled to perform a close flyby of the moon about 80 miles from the lunar surface on Monday, November the 21st. That will be including a burn by the Orion spacecraft's main engine to swing into a distant retrograde orbit around the moon. So it'll be about a 5-day transit from Earth to the moon for the Orion spacecraft, assuming the launch happens tomorrow morning or later tonight, depending on your time zone. This will be a 25-and-a-half-day mission, assuming the launch occurs tonight, with splashdown in the Pacific Ocean for the Orion spacecraft expected on December the 11th at roughly 12:40 p.m. Eastern Time in the Pacific off the coast of San Diego. One change regarding mission duration from the previous launch attempts is that just the way the moon's orbit aligns with the trajectory of this mission and orbital dynamics constraints, this will be what's known as a short class mission of about 3.5 weeks. So the Orion spacecraft will enter this distant retrograde orbit and circle the moon for one half of an orbit, a half lap around the moon, before exiting that orbit to begin its return journey to the Earth. If the launch had occurred back in late August or early September, it would have been a long class mission of about 6 weeks, and the Orion spacecraft would have completed 1.5 orbits of the moon in that distant retrograde orbit. Either mission will satisfy, either type of mission, a short class mission or a long class mission, NASA says will satisfy the mission goals, mission objectives for Artemis 1. Top of the list of those objectives is to demonstrate the Orion spacecraft's heat shield returning through Earth's atmosphere from lunar reentry velocity, which is faster than spacecraft re-enter the atmosphere when returning from low Earth orbit, such as the International Space Station, that requires a beefier, more capable heat shield, and that heat shield will be put to the test at the end of the mission. So that is the #1 objective for Artemis 1. And you may ask, what about the rocket? What about the other mission objectives? Well, in order to achieve that top objective, all of those other parts of the mission have to work. So that will assume the rocket performs as expected and the various systems on the Orion spacecraft perform in order to achieve that end goal of re-entry into the atmosphere at lunar velocity. We're now less than 4 hours until the opening of the 2-hour launch window at 1:04 a.m. Eastern Standard Time, or 6:04 a.m. UTC. At last report from NASA Launch Control, the liquid oxygen on the upper stage was in topping mode. Fast fill was completed on liquid oxygen at least. Liquid hydrogen continues loading. So we're coming up on the end of the tanking operation this evening. Still no issues of any importance reported from NASA Launch Control. A very smooth countdown so far this evening. We're now looking at a view of the interim cryogenic propulsion stage, venting visible from the vent valves as propellants continue loading onto the upper stage. That propellant loading on the upper stage should be nearing completion now. An update from NASA Launch Control indicates that the launch team is currently monitoring what they're calling an intermittent leak on the core stage liquid hydrogen replenishment system. Again, as we mentioned, once the core stage propellant tanks were fully tanked, they transitioned to replenish mode because they have to flow propellants into the rocket throughout the countdown to replace what boils off in the ambient warm Florida air here at Kennedy Space Center. So there was a short duration spike in the liquid or the hydrogen concentration from a sensor that reached about 1.5%. NASA says this is an open air sensor, so because of that, the limit is 1% for an allowable concentration of hydrogen in that area. The hydrogen concentration dipped back down and is currently at about 0.2%, below the limit. But teams are carefully watching that sensor reading to see if it creeps back up again above 1%, and if it does, the next avenue or course of action could be to send a red team to the pad to evaluate the situation and make any troubleshooting or repair attempts that may be required. That red team consists of engineers and technicians that are trained to go to the launch pad with a fueled rocket. And NASA Launch Control just reported they are in stop flow on liquid hydrogen replenished onto the core stage due to this leak. The NASA Launch Control reports that the NASA test director is working on a plan to send that red team out to the pad. That red crew that we talked about a few moments ago consists of technicians and engineers who are trained to go into the launch complex with a fueled rocket. And they're going to, if they do go to the pad, they will try to effect some troubleshooting measures to address this leak. So again, the NASA test director over at the Launch Control Center is developing a plan to send the red crew out to Launch Complex 39B. If this plan is approved, the team would attempt to tighten some nuts at the base of the mobile launcher. These nuts presumably are associated with where this leak potentially is originating. So those plans are being developed now to send this red team out to the pad. We'll let you know when we receive confirmation that the red team is indeed going to head out to the launch complex to try these troubleshooting actions to resolve this intermittent leak in the liquid hydrogen replenish system. We're awaiting a further update from NASA Launch Control here at Kennedy Space Center on the plans potentially to send a red team out to Pad 39B to troubleshoot an intermittent hydrogen leak in a replenishment valve near the base of the core stage where it connects up with the mobile launcher. If the plan is approved to send the red team out to the pad, their task will be to torque packing nuts on the area around this leaky valve. The packing nuts are in place to prevent the fuel from leaking through that connection. It's similar to a packing nut you may have on a water faucet in your home. The nut is there to hold the packing in place that keeps the water from leaking out when the faucet is on or open. Similar theory here with the packing nuts on the hydrogen system out at Pad 39B. So NASA is hopeful that just torquing these nuts in this system will eliminate this intermittent leak. So that's what they're going to potentially try to do. The last update we heard was they were developing a plan to send the red team out to the pad. We haven't heard that they have indeed departed their fallback position to head out to the launch facility yet. While the launch team continues to discuss this intermittent leak and discuss the plans potentially to send the red team out to the pad to troubleshoot the leak, there's no update yet from NASA Launch Control on whether this issue may impact the target launch time. Again, NASA has a 2-hour launch window tonight or Wednesday morning at 1:04, opening at 1:04 a.m. Eastern. The upper stage, meanwhile, is now fully loaded with liquid hydrogen and liquid oxygen propellants. Here's an up-close view of one of the vent valves. It's labeled LOX vent, so it's a liquid oxygen vent valve, allowing the oxygen gas to escape from the tank as it boils off. I believe that was on the upper stage of the rocket there. Cool view we had just a moment ago of the vent valve. Again, that view we showed a moment ago, the vent, that's not associated with the leak. That's normal venting that occurs during the countdown. The leak is believed to be in a replenishment valve down on the side of the mobile launcher, on the mobile launch platform area near the base of the rocket. NASA is finalizing a plan to send the red team out to the pad, out to launch pad 39B. This will involve sending 2 technicians and a safety lead, safety official, to pad 39B in 2 vehicles. They will enter the mobile launcher platform into an area known as compartment AB12. That's on a skid on the side of the mobile launch platform, and they'll try to torque these packing nuts. The team expects this task to take about 15 minutes to complete, and NASA officials and the Artemis 1 launch team hope this resolves the intermittent hydrogen leak in the replenishment system on the core stage. NASA says this is a hazardous operation, but the teams are trained to go to the pad with the fully fueled rocket, fully loaded with about 3/4 of a million gallons of liquid hydrogen and liquid oxygen. NASA Launch Director Charlie Blackwell Thompson has signed off on this plan to send the red team to the pad, according to NASA. And we're now awaiting the departure of the red team from their fallback position here at Kennedy Space Center to head out into the blast danger area around the pad and make their way up the ramp to Launch Complex 39B for this troubleshooting operation. We're now streaming a view from one of the cameras out at Launch Complex 39B, looking at the pad gate. Of course, that gate is open already to allow the red team to enter the pad. That pad gate was left open when the security team evacuated the area before propellant loading. So we hope to see those 2 vehicles that are carrying the 2 technicians and safety official to the pad when they arrive in the next few minutes. We're now less than 3 hours until the opening of tonight's Artemis 1 launch window, which is at 1:04 a.m. Eastern Standard Time, 6:04 a.m. UTC. We're awaiting the arrival of the so-called Red Team at Launch Complex 39B. NASA Launch Director Charlie Blackwell Thompson has authorized their entry into the pad over the next few minutes. This team will consist of 2 technicians and a safety official who will drive 2 vehicles out to the pad. They'll enter the blast danger area. That's the roughly 400-foot radius around the rocket that is evacuated of all personnel while the rocket is fueled. But this Red Team is trained to enter the pad with a mostly fueled rocket. This is a hazardous operation according to NASA. However, like I said, the team has practiced this and is trained to do this activity. This was occasionally required to make final adjustments and repairs during the Space Shuttle program once the Space Shuttle was tanked with cryogenic propellants. Other launch companies such as United Launch Alliance have also made use of Red Teams in the past as well. So this is a fairly standard type of activity that launch teams can use to get some hands-on work done at the pad if they need to, because they're limited in what the team can accomplish remotely from the Launch Control Center about 4 miles away from the pad. We're now seeing the Red Team begin to arrive at the pad. Again, this is supposed to be 2 vehicles, and we're seeing these 2 vehicles approaching Launch Complex 39B right now. They've now entered the pad gate, and they'll make their way up the ramp to the mobile launcher on top of pad 39B. Again, they're heading to an area of the mobile launcher known as compartment AB12. The leaky replenishment valve is on a skid on the side of the mobile launch platform. Again, these 2 vehicles are approaching a mostly fueled Space Launch System moon rocket to make these troubleshooting efforts to try to resolve this intermittent hydrogen leak. Again, NASA has said this is considered a hazardous operation. However, the team is trained to approach the rocket when it's fueled. And in fact, on future Artemis launches, just as they did back in the Space Shuttle program, the astronauts will be boarding the Orion spacecraft with the rocket fully tanked, fully fueled with liquid hydrogen and liquid oxygen. So this is not out of the realm of ordinary. On those future missions, the closeout crew will be at the pad assisting the astronauts as they board the fully fueled rocket. We see these 3 Red Team members, 2 technicians, and a safety official now exiting their vehicles. And they'll make their way onto the mobile launch platform here in a few moments. Now seeing this red team on the 0 level of the mobile launch platform carrying their tools. They climbed a flight of stairs to reach this point. The plan is for them to walk down another flight of stairs to reach this compartment on the side of the mobile launch platform to begin the troubleshooting effort, which will involve tightening what are known as packing nuts on a hydrogen replenishment valve that has been exhibiting an intermittent leak. So we're watching the red team. We're watching the red team arrive at the pad and walk across the deck there next to the core stage engines. Again, this is a mostly fueled rocket with about 3/4 million gallons of propellant on board, weighs more than 5 million pounds, fully loaded for launch. We've now lost track of the red team as they enter this interior compartment on the side of the mobile launcher. Not sure we'll have a camera view of them at this phase of their work, but we are awaiting updates from NASA Launch Control on the progress of their troubleshooting. And when they're complete, when they're done, we expect to see them reemerge and walk across the platform in this view once again. If you're just joining us, you're watching live views from Kennedy Space Center in Florida. We're covering the countdown for NASA's Artemis 1 moon rocket. This is the first flight of the Space Launch System rocket that's been in development now for more than a decade. This mission is an unpiloted or uncrewed test flight of this giant 322-foot tall rocket, it'll become the most powerful rocket currently operational once it takes off. On top of the Space Launch System is NASA's Orion spacecraft. This is a human-rated capsule that on future missions, beginning with Artemis 2, if this mission goes well, will carry teams of 4 astronauts between Earth and the Moon. The Artemis program is NASA's lunar exploration program that's designed and aimed at returning humans to the Moon for the first time since 1972. And right now, we're less than 3 hours from the opening of tonight's 2-hour launch window. That launch window opens at 1:04 a.m. Eastern Time or 6:04 a.m. UTC. A team of 3 members of NASA's launch team, so-called Red Team, has arrived at Pad 39B to troubleshoot a leaky hydrogen replenishment valve. They arrived at the pad a few minutes ago in 2 vehicles. They've now entered the mobile launcher into a compartment where they're currently tightening some nuts on that replenishment valve in order to attempt to fix this leak. If you haven't had a chance to do so, please hit the like button on our stream. That helps us gain a larger following for our coverage. We want to bring this exciting event to as many people as possible, and you can help us do that by hitting the like button here on our YouTube feed. Also, if you want to support our coverage, there are a few ways you can do that. One is to become a member of our YouTube channel. We have different membership levels available for you to select from. Depending on which one you choose, you can gain access to exclusive members-only video features. So please hit the join button and support our coverage in that way. You can also support our coverage by contributing in the Super Chat here on our YouTube stream. A few of you have done that this evening, and we appreciate their support. Also, please subscribe to our YouTube channel. You'll get alerts every time we're going live with launch coverage. Right now, we're waiting on a word from the NASA Launch Control Team on the status of the work of this Red Team, which consists of 2 technicians and a safety official, currently at Pad 39B at Kennedy Space Center, tightening nuts on a leaky valve. NASA TV launch commentator Daryl Nail reports that this issue is likely to eat into the overnight launch window, which opens at 1:04 a.m. Eastern and extends until 3:04 a.m. Eastern, but no specifics on that at this point on exactly how much time this issue has cost the launch team. but with that 2-hour window, there is some margin, assuming this troubleshooting is effective and resolves the leak, to get back into a replenish on the liquid hydrogen system on the core stage and pick back up with the remainder of the countdown. We're now streaming some of the ambient audio coming from the launch pad. We were streaming some ambient audio provided by NASA from Launch Complex 39B, listening to some of the sounds of the ground systems and the rocket. But that audio feed was just cut by NASA. We hope to get that back. As the red team continues their work at Launch Complex 39B, the countdown clock continues ticking. The countdown clock that we're receiving from Firing Room 1 here at Kennedy Space Center just passed T-minus 1 hour 55 minutes and counting. That is 2 hours 25 minutes until the opening of the overnight launch window, which begins at 1:04 a.m. Eastern and extends until 3:04 a.m. NASA TV's launch countdown commentator Daryl Nail has reported from his station inside the Launch Control Center that this hydrogen leak issue is likely to consume some of that 2 hour window. Don't know how much just yet. It may depend on the speed at which this team completes their work out at the pad, and then ultimately whether that work was successful in eliminating this replenishment valve leak on the mobile launch platform. This team is tightening some bolts around this replenishment valve to try to tighten that system and resolve this leak. While this is going on, the replenishment of liquid hydrogen into the core stage has been stopped. That was terminated some time ago. So that hydrogen is slowly boiling off throughout the countdown now until that replenishment can resume once this leak is fixed. It was a very smooth countdown up until this last hour or so when this intermittent hydrogen leak was detected and reported out from the launch control team. The launch team got past several hurdles early in the countdown that have cut short previous launch attempts, including the loading of liquid hydrogen into the core stage. That proceeded without incident, without any leak, any significant leak at least, earlier this evening. The team also initiated the liquid hydrogen bleed to the engine section to begin thermally conditioning the 4 RS-25 engines. That has been an issue that has affected both past launch rehearsals, countdown rehearsals, as well as one of the launch attempts a couple of months ago. No issues with those operations earlier this evening. But again, because liquid hydrogen is stored at such cold temperatures at minus 423 degrees Fahrenheit, it boils off in the Florida atmosphere, the warm temperatures here at Kennedy Space Center. And as that converts from a liquid to a gas, the team needs to replace what boils off with more liquid hydrogen throughout the countdown. That replenishment continues all the way down until about 6 minutes or so before launch, if my memory of the countdown is correct. Definitely in the last 10 minutes is when the replenishment ends and the fill and drain valves are closed to enable the tanks to be pressurized for flight. So right now, again, just to recap, we're waiting on the end of the troubleshooting operation, the work that's going on out at the pad with the red team, the 2 technicians and the safety official who arrived at the pad earlier this evening to address this leak. The team has currently been at the pad for about 30 minutes. NASA Launch Control confirms that the red team out at the pad, their work is taking a bit longer than anticipated. It was originally estimated to be about a 15-minute job. They've been at the pad for nearly 40 minutes now. About 30 minutes of that time has been spent down in this compartment with the leaky hydrogen replenishment valve. So right now the team is torquing down the bolts associated with this leaky valve, backing out of the area around that valve, allowing the launch team back here at the Launch Control Center to cycle that valve to see if that torquing fixed and resolved the leak. So it's kind of a trial and error almost type situation with the team torquing the bolt, backing off the launch controllers at the Launch Control Center, cycling the valve to see if it's still leaking. And then if it is, the team goes back in and performs more torquing on those bolts. Again, this is expected to eat into the launch window, likely will delay the target launch time this morning from the opening of the window, which is 1:04 a.m. Eastern Time, but there are 2 hours of margin in the countdown because of this 2-hour window. So the launch team has a little bit of time to work this issue. Hopefully it does get resolved and the countdown can continue and target a launch time perhaps later on into the window, which extends all the way until 3:04 a.m. Eastern Standard Time or 8:04 a.m. UTC. So we're still waiting on confirmation from NASA that this issue is resolved. We haven't got that confirmation just yet. while we await word on this critical operation out at pad 39B to try to fix and resolve this intermittent hydrogen leak. We're now 2 hours and 11 minutes from the opening of the launch window, but again, it appears likely at this point that the launch time will slip beyond the opening of the window, which is at 1:04 a.m. Eastern Standard Time. There is a 2-hour window available for this launch tonight. The countdown clock on the upper right reads T-minus 1 hour 40 minutes. Again, 2 hours 10 minutes remaining until the opening of the launch window. A 30-minute differential there. As we said before, the 30-minute differential is due to that half-hour built-in hold planned at T-minus 10 minutes. We're now expecting the red team is now departing the work site down on the mobile launcher. We may see them walk across this view in just a moment, potentially here. There they go, the red team walking by camera 808 on the deck of the mobile launch platform. Their work presumably complete. We'll stand by for an update on that from NASA Launch Control. We're seeing the red team, 2 technicians and a safety official making their way down some stairs off the mobile launch platform 0 deck down to the pad surface, where they will get back to their vehicles that they rode out to the pad in. The red team, 2 technicians and a safety official are back inside their vehicles now and driving away from pad 39B with their work completed. They spent about 45 minutes or so at the pad performing this troubleshooting work. And once the red team is evacuated back out of the pad, we expect NASA's launch control team to attempt to restart the replenishment of liquid hydrogen into the core stage. And at that point, we expect to learn whether this troubleshooting operation was successful in resolving the leak. The red team will be evacuated back to a safe fallback position. The blast danger area around the fully fueled, or mostly fueled, Space Launch System moon rocket extends to a radius of about 4,500 feet. The launch danger area is a wider expanse around the pad. Here's a view of the Artemis 1 moon rocket from a camera on top of the vehicle assembly building. That's the 525-foot tall hangar where the rocket was stacked back in 2021. That stacking began actually in November 2020 with the stacking of the first segments of the 2 solid rocket boosters. The core stage was added in June 2021, and the Orion spacecraft with its launch abort system tower was stacked on top of the rocket last October 2021. And since then, the rocket has been fully assembled for this Artemis 1 mission. It rolled out to the pad for the first time back in March for the first series of wet dress rehearsals or fueling tests. These were practice countdowns to rehearse procedures and to iron out kinks in the ground systems and the rocket before making a real launch attempt. This countdown tonight is the closest we've been to getting to the launch itself for the Artemis 1 mission. The previous launch attempts back in August and September were scrubbed before the countdown reached this point. can see here the liquid hydrogen tank on the core stage is down to 97%. This is from the boil off of the hydrogen over the last hour or two during this stop flow of the replenishment of liquid hydrogen. So NASA's launch team is planning to resume the replenishment of liquid hydrogen into the core stage and get that back up to 100%. When they resume this flow, they'll also be able to verify whether or not the troubleshooting by the red team was actually successful in resolving the intermittent leak. Once the core stage is back into replenishment mode, the launch team will be able to resume a hydrogen bleed down to the RS-25 engines. That was interrupted by the stop flow of replenishment earlier this evening. We're here with Mark Berger, the launch weather officer, who's joining us in our building at the KSC press site to give us an update on the weather forecast for the Artemis 1 launch window, which opens at 1:04 a.m. Eastern Time, runs for 2 hours. Mark, how's the weather looking right now for this launch window?
The weather still looks really good. So, of course, during tanking, we were looking at thick clouds that were moving over the Cape. And, of course, that's not a concern for tanking, but it could potentially be a concern for launch. And so we had a POV, probability of violation, of 20 at that time. We have dropped it since to 10 as those clouds have thinned out. As you had mentioned, there's a few storms offshore in the Gulf, and some of the cloudiness will spread towards us here during the window, probably more towards the end of the window. So we're watching that as well, but still an excellent chance of us launching from a weather perspective.
Can you talk about what's the threat or risk of cloud cover? What are the parameters that you're watching that you're worried about? I know it's a small probability of violation, but if there were clouds that violated the weather rule, what would be the risk?
Yeah, any type of cloud or almost any type of cloud has a risk of electrification. So, of course, in the more glamorous sense, you see lightning strikes. Of course, these clouds aren't going to produce that, but the problem is that they can also carry a charge if there's a certain thickness and at a certain altitude. So, really, if we get a mixture of ice and water in a cloud at certain depth, it can potentially carry a charge. And certainly, some of those clouds offshore that are producing lightning over in the Tampa area, those clouds, as they spread eastward, also could carry their electrical charge with them as well. So those are the kind of the two types of different types of clouds: the anvil clouds and the thick clouds that we're looking at those signs for.
So during the launch window, and it's 2 hours, so weather can change in that 2 hour period. I know we're hearing from NASA that a launch at 1:04 a.m. doesn't seem likely at this point. It may slip to later in the window. So toward the back half of that window, you mentioned the probability of violation is only 10%, but what kind of conditions do we expect? Will it be overcast? Will we still have some clear skies to enable some good visibility of the rocket? What do you expect in terms of just the visuals at launch?
I think you'll still have be able to see a few stars, but there'll probably be a little bit less transparency in the sky. So probably a high level of thin clouds will be overhead. So again, if you're close in, you'll have an almost unimpeded view of the rocket as it ascends, but you'll probably notice it catching a little bit of cloud cover as it goes through it, a minute out or so after launch.
Okay, Mark, thanks for joining us, for giving us an update on the launch weather forecast for Artemis 1. We're going to cross our fingers that the rest of the countdown goes smoothly and the weather holds for launch tonight or tomorrow morning for Artemis 1. Thanks for joining us.
Absolutely. Thank you.
An update from NASA Launch Control. The Eastern Range, the Space Force's Eastern Range. The Space Force's Eastern Range is currently no-go for launch due to a problem with one of the range's radar sites that's used for tracking the rocket after launch. So that's the news there. However, on the good news front, the liquid hydrogen replenish flow has resumed into the core stage out at pad 39B after the red team technicians torqued down bolts on a leaky valve. So that is promising news regarding the hydrogen leak issue, but the range is currently red. They've lost data from a downrange radar tracker. So we'll stand by for word on that issue. NASA Launch Control just gave us an update on the range issue involving the range's inability to access data from a radar site that's used to track the rocket. The range safety officer just told the Artemis launch team here at Kennedy Space Center that the source of that problem is a bad Ethernet switch, and the range team is replacing that Ethernet switch, and that remove and replacement work is expected to take about 70 minutes. So if you do the math, that puts us very close to the opening of the launch window at 1:04 a.m. Eastern Time before that range issue can be resolved. Notwithstanding that, the countdown is already running behind schedule due to the hydrogen leak in the replenishment system for hydrogen on the core stage. That issue does appear to be resolved, but the team lost time in the countdown during that troubleshooting effort. So we don't have any clear picture of when during the window the Artemis 1 moon rocket could be ready to fly. But the last update we received now some time ago from the NASA Launch Control Center is that they were unlikely to be able to make a launch at the opening of the 2-hour window. Again, the window opens at 1:04 a.m. Eastern Standard Time. That is 6:04 UTC, and extends until 3:04 a.m. Eastern, 8:04 UTC. you're just joining our coverage of the Artemis 1 countdown, I'll give you a brief recap of where we are. We're now an hour and 18 minutes from the opening of the launch window at 1:04 a.m. Eastern Standard Time to begin the first test flight of NASA's Artemis 1 moon rocket, a Space Launch System moon rocket, to begin the Artemis 1 test flight. The window extends for 2 hours, so that runs until 3:04 a.m. Eastern Time, or 8:04 UTC. The early phases of the countdown operations this evening progressed smoothly with full tanking of the first and second stages of the launch vehicle on pad 39B here at Kennedy Space Center. But the launch team encountered an intermittent hydrogen leak in a valve in the hydrogen replenishment system for the core stage. That leak exceeded the limits requirement for that system. A sensor detected concentrations above the 1% level. So the launch team dispatched a red crew to the pad to tighten bolts on that valve to resolve that leak. The red team spent about 45 minutes at the pad doing that work and evacuated the area. And it appears that issue is behind the launch team now, has been resolved with replenishment of liquid hydrogen restored to the core stage. This replaces the hydrogen that boils off during the countdown. The liquid hydrogen is stored at about minus 423 degrees Fahrenheit and transitions from a liquid to a gas over time because of the warm atmosphere here in Florida. So there has to be a stable replenishment of that hydrogen throughout the countdown. That replenishment, according to the launch team, has been restored. That troubleshooting work interrupted some of the other countdown procedures, so the countdown is running a bit behind the timeline for the opening of the window tonight. But we haven't heard any details or specifics on exactly how long the launch could be delayed into the 2-hour window. The other issue currently being discussed is with the Eastern Range, the Space Force's Eastern Range here at Cape Canaveral. That involves access of data from a tracking radar. The range says that issue has been traced to a bad Ethernet switch. That Ethernet switch is currently being replaced in an effort to restore access to the radar data. This radar data is believed to be required or mandatory for the launch, so this issue needs to be resolved for the flight to go ahead tonight. The launch weather officer, Mark Berger, joined us here at the KSC press site a little while ago and provided an update on the weather forecast. The probability of good weather for launch remains at 90%. There is a chance of some cloud cover to move over the spaceport later in the countdown, especially toward the end of the launch window, which may be when this mission could get off the ground given the delays in the countdown earlier in the night. But there's just a low probability that those clouds will violate any of the weather constraints. Here's a satellite picture showing some of the thicker cloud cover associated with some rain showers off to the west of the Space Center, streaming to the east. Those clouds could move over the spaceport in the next hour or two. Here's a shot from a camera on top of the mobile launcher tower at pad 39B. You're looking down at the Orion spacecraft. The Orion spacecraft is encased within an aeroshell for launch. The area with the U.S. flag and the United States writing there is the aeroshell that covers the crew module. That's the section that the astronauts will ride in on future Artemis missions. Below that, with the NASA Meatball logo and the European Space Agency insignia, that's the aeroshell that covers the service module of the Orion spacecraft, which is provided by Europe and built by Airbus. The crew module for Orion is produced by Lockheed Martin. Latest update from NASA Launch Control here at Kennedy Space Center indicates that the range estimates about 50 minutes remain in the work to swap out this bad Ethernet switch that's causing the loss of data from a range tracking radar. Again, the core stage liquid hydrogen system is back into replenish at this time. There's also a stoppage of hydrogen loading onto the upper stage of the rocket when the red team was out at the pad, and refilling of the upper stage liquid hydrogen tank is is underway now. So the launch team is posturing to get the rocket fully fueled once again. It was fully fueled earlier in the countdown before this leak was detected, trying to get back to that state as the countdown clock has just passed T-minus 50 minutes. T-minus 40 minutes, rather. An hour and 10 minutes remaining until the opening of the launch window for Artemis 1. The clock is heading toward a built-in hold at T-minus 10 minutes. That hold was originally expected to have a duration of 30 minutes. However, it could be extended to allow the launch team to make up time in the countdown. If you're just joining us, you haven't done so already, please hit the like button here on our YouTube stream. That helps us gain a larger following and a larger audience for our coverage tonight. We want to bring this countdown and launch to as many people as possible, and by hitting the like button, you're helping us achieve that. You can support our coverage by becoming a member of our YouTube channel. You can hit the join button. We have different membership levels for you to choose from depending on which level you select. You can gain access to bonus members-only video features, and you'll be supporting our coverage. Another way to support our coverage is to donate in the Superchat here on our YouTube stream. We've had several of you do that tonight. We really appreciate your support. And if you're enjoying our coverage and our efforts to bring you this live countdown and launch for Artemis 1, can register that in the Super Chat here on YouTube. The view on the left here is from a NASA camera mounted on the mobile launcher tower at pad 39B, showing one of the T0 umbilicals extending out to the Space Launch System's core stage. This is one of the umbilicals that will be retracted away from the rocket when the clock strikes 0 to allow the Artemis 1 mission to get underway. It's a nice shot from one of the launch pad cameras showing the 4 RS-25 engines at the base of the core stage. These engines are refurbished and reused and upgraded from the space shuttle program. NASA retained 16 flight-capable space shuttle main engines after the shuttle program ended in 2011. That's enough to power the first 4 SLS moon rockets. These engines are built by Aerojet Rocketdyne, and each of these engines has flown multiple times on the space shuttle program before being repurposed for the Space Launch System. Of course, the core stage of the Space Launch System and these engines will not be reused. The SLS is a fully expendable rocket. These engines and the core stage will re-enter the atmosphere and largely burn up, although some debris may reach the Earth's surface out over the a remote stretch of the Pacific Ocean. About an hour and a half after launch is when the core stage will be re-entering the atmosphere. So it will be a destructive re-entry for the core stage. No recovery planned for any element of this vehicle except for the Orion spacecraft on the top of the rocket, which is slated to return from the moon for a splashdown on December the 11th in the Pacific Ocean, assuming the launch occurs this morning. We've just passed midnight a few minutes ago here on Florida Space Coast, so we're just past midnight Eastern Standard Time. We've passed 5 a.m. UTC, and we're now 1 hour from the opening of the launch window here at Kennedy Space Center, although there is a question mark over whether the launch team will be ready to support a launch attempt at the very top of the window this morning. The window extends for 2 hours until 3:04 a.m. Eastern Time, or 8:04 UTC.
Attention all personnel and business at Kennedy Space Center Spaceport. The SLS Artemis rocket is scheduled to launch in Complex 39. And
NASA's Artemis 1 countdown clock is now passing T-minus 15 minutes and counting. It's heading down to a built-in hold at T-minus 10 minutes. So we'll see that countdown clock pause when it hits 10 minutes. We're 45 minutes until the opening of the launch window this morning here at Kennedy Space Center. No official update yet from the launch team on whether they expect to be able to hit the top of the window or whether the launch time could be pushed back later into the 2-hour window this morning. A check of all the weather parameters indicate that all launch weather rules are currently observed green at this time. No big surprise since the weather forecast called for a 90% probability of acceptable weather. And also an updated figure on the upper stage hydrogen loading status. That hydrogen tank on the interim cryogenic propulsion stage now at 75% full. That was fully loaded earlier into the countdown before the leak down at the bottom of the rocket, near the bottom of the rocket in the mobile launcher, that was repaired. So the launch team now just kind of catching up with where they should be at this point in the countdown, which the rocket should be fully loaded normally at this point in the countdown, but they're playing catch up now after falling behind due to that earlier leak. Range continues working on their radar issue as well. The Artemis 1 countdown clock is now at T-minus 10 minutes and 20 seconds. Coming up on this hold at T-minus 10 minutes. T-minus 10 minutes and holding.
Launch holding at T-minus 10 minutes.
The countdown clock has stopped as expected to begin this built-in hold at T-minus 10 minutes. This hold was programmed to have a duration of 30 minutes. However, it could be extended because the Artemis 1 countdown, the launch team is running a bit behind schedule this morning. So the hold duration can be adjusted to account for when the team believes they'll be ready to proceed into the terminal countdown. We're now about 30 minutes until the opening of this morning's Artemis 1 launch window. We're awaiting an official update from Artemis Launch Control on the timing of this morning's launch attempt. The window again opens in 30 minutes at 1:04 a.m. Eastern Time, runs until 3:04 a.m. Eastern Time. And NASA's launch countdown commentator Daryl Nail has reported it appears likely that the launch time will be delayed some length of time into the window this morning, but we're not sure how long. The Space Force's Eastern Range has reported that the Ethernet switch that was causing the problem accessing radar data that's required to track the rocket and help ensure that it stays within its flight corridor, that Ethernet switch has been replaced. So that issue, if not already resolved, appears on a path to resolution. So the big thing now is just making up for some lost time in the countdown timeline after the team fell behind schedule due to the work required to repair and troubleshoot the intermittent hydrogen leak in the hydrogen replenishment system and a valve on the mobile launcher. That issue is resolved. The leak has not recurred since the troubleshooting was completed by the red team out at the pad a couple of hours ago. And the weather parameters continue to look favorable for liftoff, with a 90% chance of favorable conditions. And all weather rules right now are currently observed green. There is a layer of relatively thin clouds over Florida's Space Coast right now, but these are not an issue for launch. They may impede a little bit of the visibility of the launch if the mission does get off the ground this morning, especially once the rocket climbs into the upper atmosphere and heads downrange. But we have clear views of the pad. Right now in the countdown sequence, if everything was on the timeline, which it's not, some of the tasks at this point would involve performing what's called the pre-start procedure on the core stage auxiliary power units. These core stage auxiliary power units, or CAPUs, power the hydraulics that steer the rocket, steer the core stage engines during flight. Also, the day of launch trajectory file should be loaded into the SLS flight computer at this time. This is the trajectory file that takes into account the day of launch conditions, upper level winds, to allow the rocket's guidance system to follow an optimum steering profile to counteract those winds as it heads into the upper atmosphere. Another activity that should be occurring about this point in the countdown, although we haven't heard any update on this, is the flight control preps on the interim cryogenic propulsion stage. This upper stage was built by United Launch Alliance for the SLS moon rocket, and the flight control preps involve a slew or steering check of the RL-10 engine on that upper stage. That should be happening about this point in the countdown timeline if the countdown was on schedule, but there are adjustments that have had to be made due to the delay earlier from that leak. Again, if you're just joining us, you're watching our live coverage of the Artemis 1 countdown and launch. I'm Stephen Clark, the editor of Spaceflight Now, reporting live from Kennedy Space Center in Florida, where we are about 25.5 minutes from the opening of this morning's 2-hour launch window. We'll ask you once again to please hit the like button here on our YouTube stream if you haven't done so already. That helps us gain a larger audience for our coverage. So please hit the like button on our YouTube stream if you haven't done so already. You can support our coverage by becoming a member. You can click the join button, and here just below our video feed, our video window here on our YouTube channel, we have different membership levels available for you to choose from depending on which level you select. You can gain access to exclusive members-only video features from our launch coverage here in Florida, and you'll be helping us maintain and expand our coverage of the launch industry and space industry, both here locally on Florida Space Coast and around the world. So if you enjoy our coverage and want us to keep going, that's one way to support us. The other way is to contribute in the Super Chat here on our YouTube stream. I want to thank those of you who have already done so this evening. We saw that Lab Padre gifted a number of memberships a little while ago. We appreciate Lab Padre's support. So the latest report from Artemis Launch Control is that the range has finished their work to replace a faulty Ethernet switch to restore some radar data. This allows the range to enter what is known as the open loop flat termination system checks. These are tests of the flat termination system that would be used to destroy or blow up the rocket if it flew off course after launch. The range, the eastern range here at Cape Canaveral, is charged with public safety. They're responsible for ensuring of minimal risk from a rocket launch to public safety. And one of the ways, the main way they do that, is all these rockets that launch from the Cape have a flat termination system. These include pyrotechnics on the rocket that would blow up the rocket if it threatened any populated areas. So the testing of that system and the range's ability to send a manual destruct command to the rocket is set to begin soon. While we wait word on potentially a new target launch time for the Artemis 1 mission, we want to air a video, an interview we conducted with Doug Hurley, a former NASA astronaut. He's now a senior manager of business development for Northrop Grumman. We chatted with Doug Hurley back in late August before the first Artemis 1 launch attempt. He, of course, flew on SpaceX's Crew Dragon spacecraft on SpaceX's first astronaut mission back in 2020. So we're going to go to that interview now with Doug Hurley. We're going to have to come back to that interview with Doug Hurley here in a few moments while we work out an issue here at Kennedy Space Center. But just an update on the status of the launch time. There's no update on a target launch time yet. However, NASA TV commentator Daryl Nail reports that it is likely that the launch time will slip from the opening of the window at 1:04 a.m. Eastern Time. If the countdown was going to remain on schedule for a launch at 1:04 a.m. Eastern Time, the opening of the window, we'd expect the countdown clock to resume in less than 7 minutes. But that does not appear to be likely as the as the launch team continues to play catch up here with some of the milestones that they missed earlier in the countdown that were delayed by this hydrogen leak that is now resolved. Also, per the normal or nominal timeline, we'd be about a minute away from the launch readiness poll. That is also not likely to happen on time. You'll notice the countdown clock remains at T-minus 10 minutes and holding, so the clock did not resume as scheduled if the NASA team was going to target the opening of this morning's launch window. So this confirms that the launch time is being pushed back sometime later in the 2-hour window this morning. We don't know how long this delay will last, but the team has until 3:04 a.m. Eastern Standard Time, or 8:04 UTC, to get the mission off the ground today. If the launch doesn't happen this morning, the backup opportunity is scheduled for the pre-dawn hours on November the 19th, Saturday morning, from here at Kennedy Space Center. I want to draw your attention to our clocks on the upper right of our feed here. As you can see, the countdown clock remains in this hold at T-minus 10 minutes. This is now an extended hold at 10 minutes. The countdown clock, if everything was on schedule, should have resumed about 5 minutes ago to count down to the opening of the launch window. The clock below, now reading 4.5 minutes, is actually ticking down to the opening of the launch window this morning. However, the launch will not be happening at the opening of the window as the Artemis 1 launch team catches up on some work that fell behind schedule earlier in the countdown. One of the two main tasks facing the team right now is completing the full fueling of the upper stage. That is currently in topping mode with liquid hydrogen on the Space Launch System's upper stage. The other main item of note right now is communications and telemetry data link checks between the rocket and the eastern range. This verifies a good command path for any destruct signal that needs to be uplinked from the Range Safety Officer console down at Cape Canaveral Space Force Station to the rocket in flight. If it flies off course, the Range Safety Officer would send a destruct command to activate the flight termination system on board the vehicle. So for public safety reasons, that's why that flight termination system exists and is on the rocket, as it is on all rockets that fly out of the Cape. And the range wants to verify they have an ability to send a destruct command to that system. That testing was delayed due to this Ethernet switch failure that has now been resolved. That Ethernet switch has been replaced, but during that troubleshooting, they fell behind schedule with that testing, which is now underway. So no estimate at all right now on when the rocket will be ready to fly this morning, but the teams remain in a posture to support a launch attempt and a terminal countdown leading up to hopefully a liftoff before the end of the launch window at 3:04 a.m. Eastern Standard Time, or 8:04 a.m. UTC. This view of the Artemis 1 moon rocket is from a camera on the west side of the pad, looking toward the east. Now 2 minutes until the opening of the launch window. Again, if you want to support our coverage, you can do that by becoming a member and joining our YouTube channel by clicking the join button. You can also contribute in the super chat here by using the super chat here on YouTube. I want to thank those of you who have contributed in that manner. Most recently, a big thank you, a shout out to Richard Tarpley for his contribution in the chat. Also, please hit the like button on our stream here. That helps us gain a bigger audience as we head into the final phase of this morning's Artemis 1 countdown. See, with that launch window open clock, we're now approaching the official start time for this morning's launch window, which is at 1:04 a.m. Eastern Time. Thank you to Bill Peterson for your support in the chat here on YouTube. And now we are inside the launch window this morning for Artemis 1. The countdown clock remains in this extended hold at T-minus 10 minutes. While we await an update from NASA on a potential new target launch time, we're going to try again to air our interview with Doug Hurley, former NASA astronaut, commander of the first astronaut mission on SpaceX's Crew Dragon spacecraft, former space shuttle pilot, Marine Corps fighter pilot, and now a senior director of business development at Northrop Grumman, the prime contractor for the 2 solid rocket boosters on the Space Launch System. Okay. We're here with Doug Hurley, senior director of business development at Northrop Grumman, also a former NASA astronaut. Thanks for joining us. We're on the cusp of another big launch, which you have a lot of experience with. You were the pilot of the last shuttle flight. You were a spacecraft commander for the Crew Dragon Demo 2 mission. You're not on this mission, you're not on the spacecraft, but it's another big day for the space program. Can you talk about your thoughts?
Yeah, I think you put it perfectly. It's just it's an exciting evolution of human spaceflight. You know, it's long overdue, in my opinion, for us to be going to the moon again. And then, you know, as we've heard, you know, using it as a stepping stone ultimately to Mars, which is just an incredible goal. So, yeah, it's just so neat to be back at Kennedy and to be ready, you know, for a launch in just a few days. I mean, an incredible amount of work has gone into this vehicle. You know, people have worked significant portions of their career already to get it to this point, which is just amazing. But we're here and we're ready to go. So can't wait for Monday.
You know, this is a test flight. We've been warned of the risks and what can go wrong. You think it's smart not to have a crew on this particular mission, or do you wish in the back of your mind that you were able to strap in, or one of your colleagues was able to strap into this test flight?
Yeah, great question. You know, my personal perspective as a test pilot, this is exactly what we should be doing. Build up approach to human spaceflight. End-to-end test of a vehicle. We're going to test it probably much more than we would with a crew on it. It's if we launch on Monday, it's a 42-day mission. The crewed flight for Artemis 2 is going to be significantly shorter. So just to get an understanding of how the hardware works from start to finish, and then be able to crawl all over everything when we get back, or look at the data, because obviously there's significant portions of the hardware that aren't designed to come back. But we're going to be able to get Orion back in the Pacific sometime in October, and get a good look at the capsule, at the heat shield, which is, you know, that's probably the biggest test objective for this flight, at least from what folks are saying, is testing that heat shield at those lunar re-entry velocities and making sure that it's safe, no issues for crew when we put them on them for the next flight.
You know, a decade ago, I think the NASA Administrator Charlie Bolden kind of identified 3 big objectives for the agency over the 20-teens, or that decade.
Yeah.
One was commercial crew, one was James Webb Space Telescope, the other was Space Launch System. And 2 of those have launched, and we're on the verge of the 3rd one. I just wanted to, you know, if you look back at the end of the shuttle program, you were a part of that. You were a part of that decade of development leading up to this point. Just your perspective on how far the agency has come since July 2011.
Yeah, I can't tell you how much doubt I think a lot of us had, not only in the crew office, but just in general in the agency. You know, at the end of 2011, what are we going to do? You know, where are we going? Now, notwithstanding, and I think it was even worse from a public standpoint, you know, it's like, okay, you guys are done flying in space. It's like, well, no, we're still flying to the space station. We're still, you know, flying crews, albeit on Soyuz rockets, but we're still doing that. But it really was a crossroads, and I give Charlie, of course, I flew with his son in the Marines, and I know Charlie really well and think the world of him. And it was a tough time, and nobody better than him to be at the helm of NASA and to point us in this direction, and then just see the wisdom that he had and the understanding that he had that we would get to this point literally 12 years later. You know, we had a successful commercial crew flight. The first one was in 2020. We've done a number of those now. James Webb, by every possible measurable, you know, I mean, it just really has done amazing. I mean, just the pictures, that picture of Jupiter that they showed the other day, it's just, you know, and then just, you know, from a personal standpoint, being part of Northrop Grumman and that success, having flown on DM2 and then now being part of SLS with the boosters, it's just, I mean, it's unbelievable. And, you know, we owe it to Charlie, not to mention the nation, to make this a success.
You mentioned those boosters here. I was wondering if you could talk about what kind of performance they're going to provide and some of the features of these boosters here.
Yeah, so a couple bits of trivia. My good friend Mark Tobias is the real expert on these boosters, but you know, so I'll just talk a little bit about the differences. So these are shuttle heritage boosters from the standpoint of the cases and a lot of the equipment. So these boosters, there are segments here that I flew on STS-127. I don't think there are any STS-135, but there's also an STS-124 booster part that my wife flew on. So we've got very good family history here. It's 5 segments, vice 4. So the 4 segment boosters were on shuttle. SLS requires bigger boosters, more oomph, so 25% more thrust, 1.6 million pounds of thrust per booster. So we've got an 8.8 million pounds of thrust at launch for the entire stack, and 7.2 of that is the boosters. So an incredible amount of power, but we understand the hardware. Obviously it's a little bit bigger, but we understand this. It's got an incredible amount of shuttle heritage, as I said. So we're excited to be, you know, that first big lift into space for SLS and Orion, and we're looking forward to Monday.
You know, I've seen a lot of shuttle launches. You know, it had a kind of distinctive crackle from those SRBs.
I was just going to say that. The crackle is what I'm looking forward to hearing. I would guess you're going to still hear that because it really kind of overwhelmed the sound of the main engines, I thought, whenever I watched one in person. And so I'm expecting to hear that same very distinct crackle of that solid rocket propellant being burnt. So looking forward to it. And hopefully if the weather cooperates, we're going to be able to even see the separation on Monday. So 2 minutes and 6 seconds. And then a little bit more SLS booster trivia. I think it's 177 feet. So they're, you know, 25, 30 feet taller than what we had on shuttle. So it's amazing. Having saw the vehicle in the VAB, you know, you get a sense of it here, but this is a huge distance between the top of the boosters, and whereas shuttle, the boosters were just kind of below the windows of the crew module. Mm-hmm. So it's amazing how huge this vehicle is.
Well, Doug, thank you for your time, and
thank you guys.
Good luck with the mission, and good luck with your new role at Northrop Grumman.
Thanks, Stephen. Really appreciate it.
That was Doug Hurley, Senior Business Development Manager at Northrop Grumman, the prime contractor for the 2 solid rocket boosters on the Artemis 1 moon rocket, also a former NASA astronaut. We chatted with Doug back in August before the first series of Artemis 1 launch attempts. He gave us his thoughts as the Artemis 1 mission was then on the cusp of launch, and now again here we are 2 months later on the verge of another potential launch opportunity for Artemis 1. There is not yet any update on a target launch time from NASA Launch Control. The launch team is evaluating how far or how much time is required to configure the rocket and prepare for a launch opportunity. The window runs until 3:04 a.m. Eastern Time. NASA Launch Control just gave us a rough estimation of a potential new target launch time. At the earliest would be roughly 1:45 a.m. Eastern Time or 6:45 UTC, but that is an approximation that has not been confirmed as the new target launch time, but that perhaps will be the earliest we could expect to have a launch attempt. While we wait an official new target launch time, we want to show you this map showing the possible trajectories for this morning's mission. If the launch had occurred at the opening of the window at 1:04 a.m. Eastern Time, the launch vehicle would have flown off to the east-northeast from Kennedy Space Center. We've labeled here a launch azimuth of 70.1 degrees that would have been used if the rocket took off at the opening of the window. At the close of the window at 3:04 a.m. Eastern Time, if the launch were to occur at that moment, the rocket would head more on an easterly trajectory with an azimuth roughly due east of 88.6 degrees out over the Atlantic Ocean. So this mission has what's known as a variable azimuth. So depending on when in the launch window this rocket takes off, that will determine exactly which direction the rocket will go. But the bounds of that launch azimuth are 70 to about 88 degrees as shown here in this map. The launch azimuth or direction changes minute by minute during the launch window. So depending on which minute it goes, it could be anywhere in this band from 70 to 88.6 degrees. This variable azimuth is necessary to achieve the target parking orbit for the Artemis 1 moon rocket, and then ultimately to achieve the proper conditions and location in space for the translunar injection burn at the what's known as the antipode of the moon relative to Earth. The opposite side of Earth from the moon is where that burn will occur, and to reach that point, the azimuth of the rocket has to change during this 2-hour window, and the flight dynamics team has calculated each of these trajectories throughout the window to ensure that the rocket will reach that proper point in space for that TLI burn about an hour and a half into the launch. What also changes during the launch sequence itself is the timing of that burn. That timing could be moved by several minutes from the approximate time of about 90 minutes after launch for the translunar injection burn. So the actual launch sequence, the timeline, will be adjusted as well during the 2-hour window. While we're waiting for an update from NASA Launch Control, I wanted to show you a couple of really spectacular satellite images of the Launch Complex 39 area. This one comes from a company called Capella Space, which operates a fleet of small radar observation satellites, some of which have launched from Cape Canaveral on SpaceX Falcon 9 rockets in the last couple of years. One of those satellites captured this radar image of Launch Complex 39. You can see Pad B in the upper center portion of this image. Pad A, where the SpaceX Falcon 9 and Falcon Heavy rockets take off from, on the lower right. The radar imager on these satellites is an all-weather day and night camera, so it can, or imager, it can take images regardless of cloud cover or lighting conditions. This image was taken back on Monday. Another really spectacular, what's known as an off-nadir view from an optical reconnaissance satellite owned by Maxar, one of their worldview satellites. This shows the Artemis 1 moon rocket on Pad 39B back on November the 12th, a couple of days after Hurricane Nicole. This satellite was off the coast of the east coast of North America, looking back generally toward the west, toward the Pad 39B in Kennedy Space Center area. This was obviously taken at a range of hundreds of miles as the satellite was well off the coast of Florida, looking back toward the spaceport. So really great views from satellites showing the Launch Complex 39 area as we await the liftoff of the Artemis 1 moon rocket this morning. The latest, most recent update from NASA Launch Controls indicated that launch would be no earlier than roughly 1:45 a.m. Eastern Time, but that's just an estimate. There's no official new target launch time yet. The window runs until 3:04 a.m. Eastern Time or 8:04 UTC. Another issue of note that has now been cleared by NASA's Artemis 1 team, but they were discussing it a little bit ago, involved an indication that some RTV, or room temperature vulcanizer, sealant or insulation on the outside of the Orion spacecraft has come loose a bit around a sensor area. Again, this is on the exterior of the Orion spacecraft. The concern there is that if that material, which is very light and pliable, were to break free, it could impact the rocket downstream in the airflow as it climbs through the atmosphere. But engineers have determined that there's no appreciable increase in risk from that. If it did break free and impact the rocket, it would likely hit what's known as the launch vehicle stage adapter, which is a very robust structure with no critical electronics or anything like that in that area, or propulsion systems in that area that could damage anything. This is similar to an issue that was assessed by the NASA mission management team on Monday, involving another strip of RTV sealant that had come free during Hurricane Nicole. And the NASA mission management team on Monday cleared that concern. And then during this countdown, they've seen another area of RTV that may be at risk of liberating during launch, but likewise, they have cleared that issue as well. So that's not going to be a constraint moving forward this morning. Here's a look at some of the major components of NASA's Space Launch System and Orion spacecraft. This graphic was prepared by Steve Kelly, one of our graphic artists, and a member of our team who works for Astronomy Now, our sister publication. The Artemis 1 vehicle stands 322 feet tall. It weighs about 5.75 million pounds, fully loaded for launch, and the 4 main engines and 2 solid rocket boosters will generate 8.8 million pounds of total thrust at launch. So here we have labeled from left to right. You can see the elements of the solid rocket boosters and the core stage, the 4 RS-25 engines, the booster, the 2 strap-on boosters. Each are comprised of 5 steel casing segments. Those are cast with solid propellant. They have been cast for about 5 or 6 years now. They were filled with their propellant back at Northrop Grumman's factory in Utah before shipment down to KSC for launch preparations. The core stage was manufactured by Boeing at the Michoud Assembly Facility in Louisiana. It has liquid hydrogen and liquid oxygen tanks. We've labeled those here as well. The 4 RS-25 engines, as we've talked about, are from Aerojet Rocketdyne and are actually leftovers from the Space Shuttle program. Moving to the right and up the rocket stack is the ICPS, the Interim Cryogenic Propulsion Stage. This is the upper stage of the launch vehicle that will take over the flight after the core stage is finished with its job about 8 minutes into the mission. The ICPS was built by United Launch Alliance. It's derived from ULA's Delta IV Heavy rocket. It has an Aerojet Rocketdyne RL-10 engine. That engine will fire 2 times. First for a perigee raise maneuver, followed by a translunar injection burn. We're getting an update now from NASA Launch Control. NASA's launch team reports that they believe they only have a few minutes of work left to do in order to catch up with the countdown sequence. The upper stage has been fully loaded now with its liquid hydrogen and liquid oxygen supply. And the mission management team is set to meet in just about 3 minutes or so to poll NASA managers on their readiness to proceed into the terminal countdown. That'll be followed by the launch readiness poll by Charlie Blackwell Thompson. You can see a view inside NASA reports that they're still expecting a target launch time to be set somewhere around 1:45 to 2 a.m. Eastern Time. But no specific launch time has been set yet. Another constraint that the NASA managers are weighing as they determine a new target launch time are cutouts in the launch window. There are 40 so-called COLAs, or collision avoidance cutouts in the window. They range from just a couple of seconds in length up to about 2 minutes in length. So there are 40 cutouts that are in the launch window that are set at specific times to ensure that the rocket, both the core stage as it flies through space, as well as the upper stage and Orion as they fly through space, don't get too close to any other object in orbit. These calculations are made with the assistance of the flight dynamics team at NASA's Johnson Space Center, as well as data from the U.S. military, which tracks all objects in Earth orbit. Now less than 2 minutes remaining until the poll of the mission management team for terminal countdown operations and launch. NASA Test Director Jeff Spaulding just reported there are no constraints to launch at this time.
proceed at this time.
I copy all entity. At this time, I will proceed with my poll. And attention on 232, this is the launch director performing the final poll for launch. Verify no constraints and go for launch. EGS Program Chief Engineer.
EGS Program Chief Engineer verifies that the EGS, SLS, and Orion Program Chief Engineers have no constraints and are go for launch.
Copy, Greg. Thank you. EGS Chief Safety Officer.
The EGS CSO verifies the SLS, Orion, and EGS CSOs have no constraints and are go for launch.
Copy, John. Thank you. Range weather.
Weather has no constraints and weather is go for launch.
Copy, LWO. And mission manager. And mission manager, launch director.
Launch director, mission manager on 232. The mission management team has been polled. You have a go to proceed with terminal count and launch of Artemis 1.
I copy all. Thank you. And entity, launch director.
Go ahead, launch director.
Yes, sir. On behalf of all the men and women across our great nation who have worked to bring this hardware together to make this day possible, and for the Artemis generation, this is for you. At this time, I give you a go to resume count and launch Artemis 1.
Copy, launch director, and thank you. All right, we do have a couple of steps to configure, and then we will be ready to resume the clock. CVSE, NTD.
CVSE here.
Initiate recording of Orion cameras at this time.
In work.
NTD.
RSR here.
Perform the booster ignition SNA arm rotation enable.
NDT, RSR, booster ignition SNA arm and rotation enable is complete.
And I copy. Thank you. All right, and all personnel, we are going to resume the clock here momentarily.
You've been listening to the voices from Launch Control, NASA Test Director Jeff Spaulding and Launch Director Charlie Blackwell Thompson. All stations polled go for the terminal countdown and go for launch.
Cutouts at this time. And
We're
all
standing
personnel,
by for
we are
the
going to resume
countdown
the
clock to resume.
GLS, you can resume the clock on your mark.
GLS copies. Countdown clock will resume on my mark. 3, 2, 1, mark.
T-minus 10 minutes and counting.
T-minus 10 minutes and counting.
The ground launch sequencer has taken control of the countdown. The ground launch sequencer is commanding the final 10 minutes of the countdown.
Show 06:47:44 is the new liftoff time.
Affirm.
Okay.
T-minus 8 minutes and 30 seconds. We're going to be hearing periodic call-outs from members of the launch team for the remainder of the countdown this morning. The launch time is targeted for 1:47 a.m. and 44 seconds. That's the exact time of liftoff, 1:47:44 Eastern Time, 6:47:44 UTC.
purging the aft skirt booster with high flow nitrogen.
T-minus 7 minutes and 10 seconds. Coming up at T-minus 6 minutes, the Orion spacecraft will be transitioned to internal power. The Orion spacecraft's ascent abort pyros are also being armed at this line.
GLS is go for core stage tank pressurization.
And we've heard the call that the ground launch sequencer is go for core stage tank pressurization.
GLS is go for FTS arm.
Now inside of 5 minutes remaining
GLS
until
go
launch
for
time.
LH2 high flow bleed check.
We've heard calls in the last couple of minutes that pressurization is underway on the core stage propellant tanks. NASA has confirmed that the 4 RS-25 engines are conditioned for launch. They're at the proper temperatures.
GLS is go for core stage APU start.
Now the 4 core stage auxiliary power units, or KPUs, are being fired up at the launch pad. These are the hydraulic power systems that power the steering mechanisms on the 4 RS-25 engines at the base of the core stage. In the next few moments, we should see the steering profile check of the 4 RS-25 engines.
GLS is go for purge sequence 4.
For the call from the ground launch sequencer controller that they are go for purge sequence 4. Inside of 3 minutes until launch. Pressurization now underway on the core stage liquid oxygen tank. T-minus 2.5 minutes And there we have the engine steering profile check on the core stage. The KPUs, the core stage auxiliary power units, driving thrust vector control actuators to check the steering profile of the RS-25 engines. These 4 engines will generate about 500,000 pounds of thrust apiece, burning a liquid oxygen and liquid hydrogen.
Internal power.
T-minus 1 minute 40 seconds. The core stage will be transitioning to internal battery power momentarily.
GLS is go for core stage to internal power.
T-minus 60 seconds, 1 minute remaining until the launch of NASA's Artemis 1 lunar test flight. Mission Control in Houston will take control of the Orion spacecraft and the launch after liftoff. At T-minus 30 seconds, the ALS, the Autonomous Launch Sequencer on the Space Launch System, will take control of the countdown from the Ground Launch Sequencer.
GLS is go for ALS.
And there's the transition to Automated Launch Sequencer, 30 seconds to go. Ignition of the 4 RS-25 engines is planned at T-minus 6 seconds.
20. 15.
T-minus 10 seconds.
GLS is go
Hydrogen
for core stage
igniters have
start.
fired. There's the sound suppression water system. RS-25 engine ignition. Booster ignition. And liftoff of the Space Launch System, Artemis 1, on the way to the moon.
Five engines on the core stage and 2 solid rocket boosters now propelling the vehicle at 128 miles per hour.
Space Launch System arcing toward the east from Kennedy Space Center.
Good control on the roll from teams in Mission
8.8
Control
million
Houston. All
pounds
good
of
calls
ground-shaking
so far.
thrust.
Now 30 seconds into the flight of Artemis 1. First milestone will be for the vehicle to pass through max Q at about 1 minute
We're
and
hearing
9
a
seconds into
big
launch.
rumble here at
This
the
is
press site
greatest
about 4
period of
miles from the
atmosphere
pad.
force on the rocket. SLS now traveling 607 miles per hour. You're looking at 8.8 million pounds of maximum thrust. Quiet here in the loops in Mission Control. The 4 core stage engines are throttling down ahead of passing through max Q. Now 1 minute, 21 seconds into the flight, traveling at 1,420 miles per hour. The 4 core stage engines are back at maximum thrust. The next major milestone will be for the solid rocket boosters to cut off and jettison at about 2 minutes and 11 seconds into the flight, so about 30 seconds from now. Again, quiet here in Mission Control Houston as teams continue monitoring.
Hope you enjoyed the sounds of the powerful solid rocket boosters on the Space Launch System. We're now about 20 seconds from the expected burnout of the 2 solid rocket boosters. They will jettison to fall into the Atlantic Ocean. They will not be recovered
Standing
on this
by
mission.
for solid rocket booster jettison and shortly thereafter.
There is burnout and jettison. Both solid rocket boosters have separated
that the solid
from
rocket
the Space
boosters
Launch
have
System.
separated these
Great view of the 4
177-foot
core
boosters
stage engines continuing to fire.
Now the core stage continues to power the
will
flight
burn
of
for
Orion,
another
all
6
four
minutes or so.
RS-25 engines firing, traveling over 3,400 miles per hour, 46 miles downrange.
Those
2
engines
minutes and
burning at
36 seconds into the
109%
flight.
of rated performance.
Hearing
as
nominal
expected.
calls here in Mission Control Houston. We've still got 4 good engines on the core stage. Next up, we'll be looking for the service module fairing to separate. This is 3 15 by 15 foot fairing panels, providing structural support, protecting the service module. Those will separate at about 3 minutes and 11 seconds into flight, and very shortly thereafter will be followed by the launch abort system separation. Just over 3 minutes into the flight of Artemis 1, now traveling over 4,060 miles per hour, 83 miles downrange. We just had
3
confirmation
minutes,
that the
15
service module
seconds
fairing
into the
has
flight.
separated.
We've heard confirmation from Mission Control Houston that the service module aerodynamic fairings have jettisoned.
And that the launch abort system pyros have fired, separating those from Orion
and we've
as
heard
well.
confirmation from
For
MCC
future crew
Houston that the launch abort system motor, jettison motor, has fired.
We just heard the call for 3-engine press, meaning if SLS were to lose an engine at this point in the mission, we could still achieve a nominal mission. We would just have an extended main engine cutoff time. However, we still have 4 good engines, all at maximum thrust right now, powering the first flight of Artemis at 5,200 miles per hour, 148 miles downrange.
Four minutes, 10 seconds into the flight. We're about halfway through the core stage's performance on this Artemis 1 test flight. No issues
We're 4
reported
minutes and 16 seconds
so far
into the
in
flight
this
of
launch.
Artemis 1.
4 RS-25
so
engines
far, we've
continue
had
firing.
a clean ascent.
A clean
we
ascent.
saw those solid rocket boosters
reported from
jettison
Mission
about 2
Control
minutes and
in
11
Houston.
seconds after liftoff. Shortly after, we had the service module panels fairings separate, as well as the launch abort system. The launch abort system was inert for this flight, except to perform this separation. Those 4 core stage engines will continue to fire and power the flight of Artemis 1, now traveling over 6,800 miles per hour, 229 miles downrange. Booster flight controller reports that the engines are looking good.
5 minutes into the flight, 3 minutes remaining in the
Our
core stage burn.
main
All
engine
4
cutoff
engines
time is about 8
continue
minutes
firing.
and 3 seconds. We are now at 5 minutes and 11 seconds into the flight, 7,656 miles per hour. Again, 4 good core stage engines, those 4 RS-25 engines. The last time those core stage engines flew, they were taking space shuttles to orbit, and now with upgraded capabilities, they're launching the future of human spaceflight.
4 minutes, or 5 minutes, 40
5 minutes,
seconds
42
into
seconds
the flight.
into the mission. We are now traveling
Velocity
8,800
now
miles per hour,
8,800 miles per hour,
345 miles
345
downrange
miles
from the launch pad at
downrange.
Kennedy Space Center.
Everything looking good. A little more than 2 minutes remaining in the core stage burn.
Again, we are anticipating core stage main engine cutoff at about 8 minutes and 3 seconds. And about 10 seconds later, we'll see core stage separation, at which point Orion and the interim cryogenic propulsion stage will be
Space Launch
flying
System
free.
core stage engines continue to be visible from our location here at Kennedy
Now
Space
traveling
Center
over
on the
10,000
eastern
miles per
horizon.
hour, 6 minutes and 15 seconds into the flight of Artemis 1, 427 miles downrange. Quiet here on the
A
loops in Mission
starlight
Control Houston. Teams
beacon
continue
on
to
the
monitor
eastern
this
horizon
first
as
flight.
the Space Launch System continues downrange. Plus 6.5 minutes.
About a minute and a half now until that core stage main engine cutoff time. Our 4 core stage engines continue to fire maximum thrust.
Here's a neat animation from NASA showing what the current configuration is of the Space Launch System. The 2 boosters jettisoned, as we saw a few minutes ago. All 4 engines on the core stage continue firing.
Coming up on 7 minutes since launch today, now traveling over 12,800 miles per hour, 563 miles downrange. Again, still quiet here in Mission Control Houston.
miles downrange. Artemis 1 has now disappeared from view behind some clouds just above the eastern horizon.
As we prepare for main engine cutoff, the 4 RS-25 engines are beginning to throttle down. 30 seconds now until core stage main engine cutoff. All 4 engines continue to throttle down.
The 4 RS-25 engines are throttling down to maintain a constant acceleration
Now 7 minutes,
on the
45
vehicle.
seconds into the flight,
As we
traveling over
approach main engine
16,000 miles per
cutoff,
hour.
16,000 miles per hour, the current velocity.
Continuing to hear good calls here in Mission Control, Houston. We're standing by for core stage main engine cutoff.
MECO, main engine cutoff.
And we have confirmation of core stage main engine cutoff. Orion is now in Earth's orbit. The Flight Dynamics Officer reports that we have a nominal main engine cutoff. And we just heard the call for core stage separation. That means Orion and the interim cryogenic propulsion stage are now flying free from the core stage of the Space Launch System. The next milestone will be solar array deployed approximately 18 minutes after liftoff. But before Orion stretches its wings, let's check back in with our friends at Kennedy Space Center and hear all about
At this point, the ICPS, the interim cryogenic propulsion stage, and Orion are in a preliminary orbit around the Earth. In this orbit, at least according to predictions, the spacecraft should be in an elliptical orbit ranging between about 16 nautical miles and more than 900 nautical miles in altitude. That low point or perigee is within Earth's atmosphere. That's why the RL-10 engine on the upper stage needs to ignite at about 53 minutes or so after launch for what's called a perigee raise maneuver to raise that low point or perigee above the atmosphere. That'll put the Orion spacecraft in a stable orbit. Right now, the core stage, which has been jettisoned, as well as the ICPS and Orion, are on a trajectory that would result in a splashdown in the Pacific Ocean after completing nearly one orbit of the Earth. So this upper stage has some work to do initially to reach an Earth orbit, and then it'll be followed at about T plus 90 minutes by the translunar injection burn. One of the next milestones will be the extension or unfurling of the 4 solar array wings on the service module of the Orion spacecraft. This is one of the European elements of the vehicle. That is set to begin at about 18 minutes, about 8 minutes from now, 18 minutes after launch. And that will take roughly 12 minutes or so to complete. Those solar arrays are necessary to begin recharging the batteries on Orion. We're now going to listen to some remarks from the Launch Control Center from Launch Director Charlie Blackwell Thompson following this morning's launch of the Artemis 1 moon rocket.
Well, for once, I might be speechless. So you guys know I have talked a lot about appreciating the moment that you're in. And we have worked hard as a team. You guys have worked hard as a team for this moment. This is your moment. It is not by chance that you are here today. So I want you to look around at this team and know that you have earned it. You have earned your place in the room. You have earned this moment. You have earned your place in history. You were part of a first. Doesn't come along very often. Once in a career, maybe. But we are all part of something incredibly special, the first launch of Artemis. The first step in returning our country to the moon and on to Mars. What you have done today will inspire generations to come. So thank you. Thank you for your resilience. You know, I said at the pre-test briefing, the harder the climb, the better the view. We showed the Space Coast tonight. What a beautiful view it is. So congratulations. So we got a couple of traditions here in launch control. And the first one is when you're in the position for the first time, you get a tie cutting. And so I have my launch director scissors. And I'm going to get my tie cut by a couple of legends that are here. And then anyone who wants their tie cut will be making the rounds in the firing room. You got your console chiefs. If they want to do it, that's fine. If you want me to do it, you might have to wait a little while, but I'll stay all night if I have to. It'll be my pleasure to cut ties. So I'm going to take care of mine, and then I have one other presentation that I want to make this evening.
Former NASA launch directors Mike Leinbach and Bob Seek are with Artemis 1 launch director Charlie Blackwell Thompson in firing room 1 of the Launch Control Center. This is a tradition, the tie cutting tradition for new launch directors.
This is Charlie Blackwell Thompson, Artemis 1 launch director. She just got her tie cut. That is a tradition here at NASA. We just got to hear her talk to the team, and one thing that really stuck out to me that she said is that they really earned
Yes, we're here in Mission Control Houston, still monitoring the Artemis 1 mission and the first flight of Orion atop the Space Launch System. So far, we saw successful liftoff at 1:47 a.m. Eastern Time, all the way through separation from the core stage. We now have Orion and the interim cryogenic propulsion stage flying free. And we've just heard that we have initiated solar array deploy. So we are turning our focus to that. The spacecraft was running on battery power, but stretching these wings will allow it to stop relying on those batteries and significantly extend the time it can stay in space. So solar array deploy takes about 12 minutes. We have 4 solar arrays that we need to deploy and latch. These will provide
So we're awaiting the next milestone after that ceremony in the Launch Control Center. Attention is turning back to Mission Control in Houston, where we're where the team is monitoring the status of the Orion spacecraft as it's coasting through space at a velocity of more than 17,000 miles per hour. We're awaiting the start of solar array deployment. The 4 solar array wings on the Orion service module are derived from the solar arrays that were used on the European Space Agency's automated transfer vehicle. They will deploy into an X-wing configuration. This deployment takes about 12 minutes. The solar array rings span 63 feet tip to tip. Mission Control in Houston confirms that all 4 solar arrays have been released from their launch restraints. And now we're seeing live video from the Orion spacecraft showing the deployment sequence. Here's a live view from the Orion spacecraft. You can see some of the reaction control system thrusters there. And now a view of one of the solar array wings deployed. Actually, you can see 2 in this view, extended. Now 22 minutes, 25 seconds into the Artemis 1 mission. NASA has confirmed that all 4 solar arrays on the Orion spacecraft have deployed. They are oriented in an X-wing configuration. These solar panels were built by Airbus as part of the European contribution to the Orion program. They built the Orion service module. We're seeing this view from one of the solar array wingtip cameras looking back at the interim cryogenic propulsion stage or upper stage of the Artemis 1 moon rocket. You can see some of the reaction control system thrusters here. Again, just to recap one of the latest reports from Mission Control in Houston, the solar arrays are fully deployed. So with the solar array deployment complete, the next major milestone will be the perigee raise maneuver using the RL-10 engine on the upper stage. That is a planned 22-second burn that will place the Orion spacecraft into a stable low Earth orbit. Right now, the perigee or low point of that orbit dips within Earth's atmosphere. So the goal of this next maneuver, the PRM, is to raise that perigee above the atmosphere. Now 31 minutes into the Artemis 1 flight to the moon, we're now streaming a view, or streaming this Artemis logo, which is what NASA is providing us on a technical feed when there's no live downlink from the spacecraft. So we expect to get some periodic views from the spacecraft during the mission, during the rest of the launch sequence. Here's a live shot of the empty pad B, where the Space Launch System blasted off 31.5 minutes ago. You can see the fire suppression and water out there at the pad to ensure there's no risk of fire after the launch of this powerful new rocket. Here's a live view again of Launch Complex 39B here at Kennedy Space Center. 36 minutes since the launch of the Artemis 1 moon rocket. The next big milestone will be the perigee raise maneuver by the upper stage engine. That's a 22-second burn that is set to get underway at T plus 53 minutes. That is going to be around 2:40 a.m., give or take, Eastern Time for that perigee raise maneuver. 43 minutes, 40 seconds into the Artemis 1 mission. We're now getting some live downlink video from the Orion spacecraft. You can see here the solar arrays tracking the sun. Each solar array wing has actuators that articulate, can tilt and pitch the arrays to track the sun, and they also actually can tilt backwards during burns of the RL-10 engine as well as the service module engine. Looks like that's what these arrays are doing now, getting into a configuration for this next burn of the RL-10 engine, the first burn of the RL-10 engine actually, the perigee raise maneuver. We're now showing some animation of what the current configuration of the Space Launch System upper stage and Orion spacecraft looks like. Those European solar arrays have been folded back in preparation for the upcoming perigee raise maneuver in about 2 minutes' time. This burn will place the Orion spacecraft into a stable low Earth orbit. Without this burn, the Orion and upper stage would re-enter the atmosphere over the Pacific Ocean before completing its first orbit of the Earth. So this perigee raise maneuver will ensure that the Orion is placed into an orbit that is stable, where it will remain in space. That will be followed by a TLI burn, translunar injection burn, at about 90 minutes after launch, around 3:15, 3:20 a.m. Eastern Time. That will send the Orion spacecraft toward the moon. Standing by for ignition of the RL-10 engine on the interim cryogenic propulsion stage. Ignition confirmed on the perigee raise maneuver. This is a 22-second burn. This view comes from a wingtip camera on one of the solar arrays of the Orion spacecraft. You can see a little bit of motion there imparted from the engine. PRM cutoff. A good burn reported from Mission Control in Houston. So at this point, the Orion spacecraft should be in a stable low Earth orbit. Again, Mission Control reported a good burn, a good perigee raise maneuver by the RL-10 engine. Now 55 minutes since launch. This data indicates that the Orion spacecraft is about 1,100 miles above Earth's surface. This perigee raise maneuver was anticipated to raise the perigee or low point of the orbit of Orion and the upper stage or ICPS to from about 20 miles to about 115 statute miles above Earth's surface, and all reports that we've received from Mission Control in Houston indicate that it did just that. It was a good burn. The next maneuver is scheduled at about 90 minutes after launch, about 30 minutes from now. That will be the translunar injection maneuver. That burn will last about 18 minutes. And just a bit of trivia, that will be the longest ever burn in space by an RL-10 engine. Those of you who follow the launch business will know that the RL-10 is a workhorse for upper stages. It's been used on numerous launches in different configurations and different versions since the 1960s. In fact, more than 500 RL-10 engines have flown in space on Delta, Atlas, and Titan rockets. And among all those missions, the upcoming 18-minute burn will be the longest ever firing of an RL-10 engine in space. Aerojet Rocketdyne, the engine manufacturer, says they have test-fired RL-10s for longer during ground testing. Now, an hour has passed since the Artemis 1 launch. We've added a countdown to our clock on the upper right of this screen until the translunar injection burn. That translunar injection burn is set to begin at 3:14 a.m. Eastern Time, about an hour and 26 minutes after launch. And the RL-10 engine will fire for 18 minutes to place the Orion spacecraft on a translunar trajectory to begin the 5-day journey out to the moon. So 17.5 minutes left until that start of the ignition of the TLI burn. Now, about 10 minutes remaining until the translunar injection burn with the interim cryogenic propulsion stage. Now less than 4 minutes until the translunar injection burn. The burn is set to get underway at a mission elapsed time of 1 hour, 26 minutes, and 41 seconds. "45 seconds until the ignition of the translunar injection burn. "30 seconds until the TLI burn ignition. See the solar arrays on the Orion service module are swept back in the proper configuration for this upcoming engine burn that is due to last about 18 minutes. 15 seconds until ignition. TLI is underway. Translunar injection burn has started on the interim cryogenic propulsion stage. This is an 18-minute burn that will add velocity to the rocket and the Orion spacecraft to escape the bonds of Earth's gravity and place them on a trajectory toward the moon. This burn is timed for when the Orion spacecraft is at the what's known as the antipode from the moon. So it's on the opposite side of the Earth from the moon's position in space. You can see this velocity meter is increasing, now 18,270 miles per hour, as the RL-10 engine produces about 24,750 pounds of thrust at full throttle. Now a little more than 3 minutes into this 18-minute burn. Here's a view inside the Mission Control Center, Mission Operations Room, at the Flight Control Room at the Johnson Space Center in Houston. This is the team that is overseeing the operations on board the Orion spacecraft. This translunar injection burn will be adding about 6,325 miles per hour to the velocity of the Orion spacecraft. That's an increase in velocity to accelerate the capsule away from the Earth and on a trajectory toward the moon. This is going to be a 5-day outbound leg of the trajectory for the Orion spacecraft to reach the moon, culminating in an arrival maneuver, an outbound powered flyby about 80 miles from the lunar surface early on November the 21st, on this coming Monday. That will begin the process to swing the Orion spacecraft into a distant retrograde orbit around the moon. It will remain in that orbit for half a lap around the moon before departing that orbit, performing another flyby of the moon, about 80 miles from the surface, for an inbound powered flyby that will send the Orion spacecraft back toward Earth, targeting a splashdown in the Pacific Ocean west of San Diego on December the 11th. About a 25-and-a-half-day mission on tap for Artemis 1. We're now past 7 minutes into this 18-minute translunar injection maneuver. Now passing 9 minutes into this 18-minute burn, halfway through the translunar injection maneuver. Again, this is an 18-minute burn, the longest ever firing of an RL-10 engine in space to date, in a legacy that includes more than 500 RL-10 engine flights dating back to 1963.